Peter is not here yet. MariaDB is basically 6 years old, launched in February of 2010, our first GA release. Drizzle never really made many releases. They never really got too much adoption, and we'll go into why they kind of didn't quite work out, I guess. Anyone used Drizzle before? Okay. And WebScale SQL was announced in March of 2014. Has anyone heard of or used WebScale SQL? Interesting. And WebScale SQL started off as a consortium of companies deciding to actually make MySQL better. And these companies, it turns out, have a lot of MySQL hackers. As Facebook probably easily has 30 odd, maybe even 40 MySQL hackers. Google probably has close to 20. The folk at Twitter have at least 2 or 3. So it turns out that the MySQL hacker community outside of MySQL is also pretty vibrant. So you can kind of go through a little bit of a history of MySQL, because you kind of have to know your past before you know your present and future. I'm going to take a wild guess that many people didn't use Unireg. Did anyone here use Unireg? I wasn't even born. Yeah. Monty actually started making a text user interface to an ISAM data store where the rows were written to disk and the indexes were kept on top of that. And basically he had this setup where you would actually have forms to enter data. And this is where you see these FRM files that if you look inside your MySQL data directory, where they come from, they're actually forms to enter data. So if you think of it in the way of how Access is a database, you enter stuff into a form and it stores in a database. Then, sometime along the lines, you'd see that MSQL came as freely available but not open source. So Monty basically decided to plug the ISAM data store to MSQL. And then in '95, when the internet was starting to get popular, I mean, I'm going to take a wild guess here that most people got their first internet connections here around 94, 95. I mean, that's when it started becoming pretty available to commercial users. AOL started sending out free CDs, Prodigy, etc. I know this because they'd send the CDs to Malaysia too, for some absurd reason. So Monty, alongside Larson and David Exmark, founded MySQL AB in '95. '96 was one of the first releases that one would say was fairly usable. It powered things like /dot. People still read /dot, yes? Maybe? Well, /dot was all the rage. Maybe today it's Hacker News, I don't know. And then in 2000, Monty and the rest of MySQL AB made a pretty phenomenal decision to actually make it GPL, make a database server GPL. It was also shortly thereafter, and I guess many of you probably also use Linux. Using Linux in 1995 versus, or 2000 versus 2016 has got a vast difference. Like in 1995, you'd probably have to, work out how to write a modem driver. Today, you just plug it in and ETH0 just works magically. And who uses a modem anymore? So shortly thereafter, they decided that a good way to make money would be to actually create a dual license, especially around the client library, because it's hard to make money from, well, it's hard to get GPL software embedded, I guess. And then the holy grail was statement-based replication. So you didn't have to scale up, you could scale out. It's not the best form of replication. As you'd see later on, we introduced things like row-based replication, but statement-based replication means you could buy many, many cheap white boxes and actually have reads scaled out. And if you think about the evolution, May 2000 is when you'd have statement-based replication. And in the Postgres world, replication out of the box basically only came around September 2010. It's a huge delta before out-of-the-box Postgres became as usable as MySQL from a replication standpoint. 323 was probably very popular and was at one stage one of the last client libraries that were actually shipped because of the license change. And it took a lot of convincing till maybe around 2004 or 5 before other Linux distributions started shipping the LGPL client library with the FOSS exception. 2001 also brought InnoDB, which presumably all of you use today. Who here does not use InnoDB? That's what I thought. And InnoDB brought transactions, MVCC. It wasn't MyISAM any longer. If it crashed, it could recover. And many people were excited by this. It made MySQL a real database. Real. It was always a real database. And then in 2001, you'd have VC dollars, and Martin Mikos comes over from Solid to actually become the CEO. He was the CEO till he led the company to an exit, actually. And in 2002, MySQL also did something quite interesting. The NewSphere case with the Gemini storage engine was basically the first test of the GPL in the courts. It showed that the GPL is actually enforceable. Gemini was eventually open sourced, but then abandoned. And if you're still interested in finding the Gemini engine, Anthony Curtis, who occasionally comes to these SCaLE events, actually has a tree sitting on Launchpad, possibly now GitHub, that you could take a look at. 2003, with Series B money, was also the time that engineering was invested in really heavily. We had a huge growth spike in terms of engineers and everything else that came along with it. And it was pretty interesting that when 4.0 became GA, there were 2 alphas at the same time as well. It turns out that shortly thereafter, SAP was also realizing that it makes sense to make MySQL a real database. They wanted views, they wanted triggers, they wanted stored procedures, etc. And at the same time, they had this idea that it might make sense to also create another SAP compatible database called MaxDB, written in Pascal. You can still probably download the sources to MaxDB and get it running with free Pascal today. I haven't done it in quite some time, but free Pascal ships at least in Debian. 2003 also meant that Alzato got acquired, and that brought in NDB cluster, and pretty much every other cell phone home location recorder runs NDB cluster today, I would say. It gives you 5 nines uptimes, and it's improved tremendously. I mean, previously it was only in-memory storage, then it gave you on-disk storage, and Oracle has put huge amounts of effort into making NDB cluster better today. In fact, deploying NDB cluster, upgrading it used to take like 54 commands or something, but now Oracle has actually, at least from OpenWorld last year to now, have improved tremendously how you'd manage NDB cluster, thus making it a possibly more usable and usable database, as in you didn't have to be spending millions of dollars and figuring out how to actually do stuff. So I think this is going to be really interesting going forward as well, so kudos to Oracle. In 2004, 4.1 became GA, and then you also have NDB cluster. And it turns out that because of all that money we'd raised, pretty much all the external developer community got hired. If you wrote a patch, you probably got hired. If you hung out on the IRC channel, you probably got hired. You probably go through like 5 or 7 interviews, but getting hired was really, really easy. Because if you were passionate, the company had the money, they would pay you to work anywhere. And then 2005 brought us the 5.0 tree, and And frankly, that was one of the first releases that I had noted where the ABI got broken when it became GA. It was broken actually by Monty, and one of the first things I had to do was tell Monty, hey, you broke the ABI. It was kind of a terrible release, but it had lots of enterprise features. So it had the views, triggers, thought procedures. It was definitely driven by marketing. And I would say that even internally to get it running on, say, Eventum, which is a support database, it took close to like a year. So it became GA quite much later. Now, something else happened. Oracle decided to acquire Innobase, the makers of InnoDB. So Oracle has had its foot in the MySQL world since 2005. And we were all terribly worried, like, oh my, we need like a transactional storage engine. How is this possible if our competitor owns a transactional storage engine? So Monty started with a few engineers the Maria project to make a crash-safe and transactional version of MyISAM. When times of crisis hit, the next best thing to do is raise more money. So we took even more investment. And that meant we could now acquire Netfrastructure and give you the Falcon engine, which was supposed to be able to store blobs, was good at blobs. It was Jim Starkey engine, had MVCC, and was meant to solve the InnoDB problem. And at the same time, we said, look, we're not going to just be dependent on MyISAM and InnoDB and or Falcon. We want everyone to write engines. We'll make a pluggable storage interface so that anyone can write an engine. And at its heyday, there are probably like 40 pluggable storage engines out there. Like you could stream HTTP inside, and you could do write to S3 buckets and so forth. As for quality of the engines, they vary tremendously. So not all were fully supported and so forth. So we were the only database manufacturer with a pluggable storage engine architecture. This is not true anymore. I mean, today you have MongoDB with storage engines for now about a year plus. You have Postgres, I think, talking about it as well. And it turns out that MySQL cluster development was starting to happen at a rapid pace. They said the server is being developed too slowly, so we're going to fork internally. So MySQL cluster actually had its own fork. Might have been the first MySQL fork sanctioned by the company. And they put cool stuff in, like row-based replication, circular replication, online DDL, all this in the cluster fork. And NDB, because it was bought and then tacked on to the SQL interface, was actually probably the first NoSQL engine out there, because you could have other interfaces to NDB without a SQL interface. You could use it as a key value store from the start. You could use LDAP front end with NDB backend, and that worked as well. So when people think that forking of MySQL only happened shortly before Oracle picked it up, NDB had already forked years ago. 2006 also brought along another engine, PBXT, which was, again, in some instances performing better than InnoDB, especially right before they kind of killed it. It had a log-based design. It had pretty good performance. But sadly, you don't really hear of PBXT much anymore. It only got shipped in a few releases of MariaDB before it died. And you think, right, what makes engines different? And there are a whole bunch of things, like how it's stored, maybe on disk, the type of indexes it uses, does it support transactions or not, locking levels, caching, backups, foreign keys. All of this was basically given to the engine to handle. And this is a different way if you look at the MongoDB world, how they're making it. They're actually giving you things like GIS in the server. They're actually giving you things like many other things in the server, and the engine doesn't have to provide as much. So it's much easier to write an engine. And anecdotally, you can see that the RocksDB engine that Facebook is basically running in production with something called MongoRocks for the Apaz servers today. And it took them less than a year from the time the engine interface was announced to the time that this was integrated and running in production, which is phenomenal, because getting an engine in the MySQL world stable in less than a year and in production, pretty hard task. So November 2007, MySQL 6.0 alpha came out as well, and we were regularly working on the 5.1 tree. We spent most of 2007 being extremely quiet. We were planning to IPO the company. 6.0 brought interesting things like online backups, so in-server online backups, and there's not much of this that's still available on the internet today. I think all the trees have been taken down, except if people still have copies. But there is at least one video on YouTube that talks about online backup. History gets erased pretty quickly on the internet. So obviously we didn't IPO. Sun bought us. And shortly thereafter, the Drizzle fork started. They realized that they should fork MySQL 6, make it modular, make it more microkernel in terms of an architecture, have UTF-8 out of the box. And this was a special team within Sun Labs that could work on this. November 2008 also brought the 5.1 GA. And there's a theme building up here. When 5.0 was GA, it was clearly not a GA release. When 5.1 was GA, it was clearly also not a GA release. And then, but Monty discovered how to blog. So he actually wrote this really long blog post about bugs in 5.1. So you can kind of tell that Monty was getting ready to exit the company sooner rather than later. Now, a lot of people don't give much thought to R-delta binaries and the work that R-delta did. Anybody remember R-delta? Okay. R-delta actually decided that they would take on these patches that were coming from the community and actually make binaries, make supported binaries. And their only claim to fame was, look, when we give you these binaries and RPM repositories and Debian repositories, back then no one else provided this, the only thing they'd expect in return was you to actually file bug reports, or if you felt like you needed to buy services, you could visit OpenQuery. That was actually pretty interesting. And they built this system called the bakery, which survives till today because MariaDB makes use of the bakery to some extent. It's a pity that they stopped building binaries, and I guess it's largely because resources were crunched, and they were building largely on Percona's patch sets as well. And Percona decided that they would stop making a patch set and actually release, I think, was it 1.02? So around December 2008 is when Percona basically said, here is Percona server 1.02, enjoy. And it wasn't called Percona server, it was probably called Percona SQL. They had a whole bunch of names before they actually settled on Percona server. They even had these builds called the hyperf builds. And that graph I show you there is picked out from 2009 when Flickr themselves said they had migrated to the hyperf build, and they made it public that they'd done that. So Flickr was one of the early adopters of the Percona server hyperf build. And you would see that Wikipedia had a patch set that came out from Domas. There was an InnoDB plugin for AIO read improvements, and a lot of other Percona patches overall. So Percona, Google, and Facebook were the people who were actually making MySQL better even then. And R-delta, again, we're taking the Percona patch set and putting things like the micro slow patch for slow queries. They had a faster master promotion, which they taken out of the Google patch. So there were all these little patches that they were actually building binaries for. So there was an active ecosystem then too. I should probably also mention at some stage that there was Proven Scaling in between, who are republishing MySQL Enterprise binaries because they had bought a subscription and then they'd given it to you, binaries and source. In February of 2009, Monty basically decides to leave Sun. And you will actually note very carefully that it was only in April 2009 that Oracle proposed to acquire Sun. Monty had already left Sun before Oracle had proposed to acquire Sun. This part of history occasionally seems to get muddled. There was also a final 6.0 alpha release, which was kind of pretty much dead. This was the last of the 6.0s. Basically, at this stage, you would see that Falcon was dead. Drizzle was not looking very promising. But what did happen after Oracle proposed the purchase of Sun was that Monty program was started shortly thereafter. And there was a long battle in the EU. And all this happened at the MySQL conference in Santa Clara. It didn't take very long before there was a beta release of MariaDB 5.1. There were a whole bunch of MariaDB releases in between, which is why you'd understand eventually this numbering scheme where MariaDB goes from 5.5 to 10.0. It was because, I guess, it took time for Oracle to actually buy Sun, and it also took time for Oracle to actually make a GA release from 08 to 2010. But when 5.5 came out, it was heralded as a pretty good release. People really enjoyed 5.5. In fact, MariaDB rebased on 5.5 as well. So you'd realize that the 5.2 and 5.3 trees were built on 5.1, but 5.5 was built on 5.5 as well. And it didn't take very long for Percona to release Percona Server 5.5 stable as well. And there are obviously various things being peppered into releases, like 5.2 had the idea of virtual columns. It was a release that was filled with community features. 5.5 had a lot of InnoDB performance improvements that came from Oracle, as well as MariaDB and Percona. You'll now note that there was a pretty huge delta to get MariaDB 5.5 out. It was 16 months after MySQL 5.5, and that was largely because of all the merging and the code changes that had gone in when it became clear that this model of merging with such huge changes, especially in the optimizer, was probably quite unsustainable. The MariaDB Foundation, anybody heard of this one? Okay. So yeah, they announced a creation in London, November 2012. And then it wasn't much longer after that MySQL 5.6 became GA. So here we were with 5.5 and 5.6, and we thought sometime in late 2012 that 10.0 was going to be the next number because we knew 5.6 was going to be worked on, but we didn't expect 10.0 to take such a long time to make as well. Around that time, SCaLE picked up Monty Program, SCaLE being this venture-backed company, Monty Program being a band of hackers just working. And Percona Server became GA as well. And you'll notice that they also had a delta because when Percona believes in doing heavy QA, heavy testing, and they also wait for all the bugs in bugs.mysql.com to get fixed. And this is no testament to the quality of 5.6. 5.6 maybe at GA wasn't so hot, but after a couple of releases, it got really, really, really rock solid. I mean, 5.6 is what powers a lot of the internet that you see today. So, again, a testament to Oracle learning and fixing things and being responsive to their users extremely quickly. And then, 2014 brought us MariaDB 10 GA, so kind of a little delay there. And around the same time, they realized, the consortium of web companies realized that there will be a WebScale branch which they will use as a base. So Facebook uses it as a base to actually add more features inside their tree. And other companies are more than welcome to do that as well. It's probably also worth noting that a lot of Linux distributions, by the time 10.0 came out, had also paid close attention to MariaDB. And Percona had also started paying close attention to Linux distributions and started working closely with the Debian and Ubuntu teams, I guess, including with Galera Cluster, because Galera Cluster and Percona XRDB cluster becomes tremendously important when it comes to the OpenStack world. Anybody use OpenStack? Okay, brilliant. So, before we go to the talk about, I believe the next slide should be the one where I talk about Codaship. I'm going to tell you that there is something else that's worth mentioning as a milestone, that in October of 2015, separated by 2 days, MariaDB 10.1 became GA, followed by MySQL 5.7 becoming GA. So today you have 2 fairly new GA releases that you can kick the tires around for. Codeship. They aim for at least 3 releases a year, and just a couple weeks ago in January, they did make a release as well. And their upstream is galeracluster.com. They've been open source for probably in excess of 6 or 7 years. There are 2 major distributions of Codeship's Galera cluster. There is Percona XDB cluster, PXC, and MariaDB Galera cluster, MGC. And PXC is right up until MySQL 5.6 plus Galera, because Percona has not released Percona Server 5.7 yet. And MariaDB Galera cluster is right up to 10.1. And there are plenty of users of Galera cluster out there, including people like Greets, HP DNS as a service, OpenStack, Mercado Libre, PagerDuty, AVG. The list goes on. This is something that OpenStack people love as well. Now, when it comes to the open source community, I'd say that generally speaking, MariaDB not only takes external contributions, they also are very, very kind to external committers. So after enough contributions, you can get commit rights relatively quickly. MySQL has also been very good with taking community contributions. They're definitely welcome, but so far the commits are not, and we hope that will change at some stage. And put MySQL's already moved to GitHub. It's so much easier to just submit a pull request. It's easy to fork, make a change, and submit a pull request. And I'm hoping that that will change in the near future. And one of these features that I think were pretty good would be generated columns. I mean, that was a patch that sat in bugs for like maybe 10 years. And it doesn't matter if MariaDB took it 5 years earlier, but it's still a case of it sat there for 10 years. If you're a contributor and you wait a long time before your feature gets accepted, you get pretty annoyed pretty quickly and go move on to something else. WebScale is much quicker when it comes to accepting patches, even if you don't work at Alibaba, Facebook, Google, LinkedIn, or Twitter. Now, Google is an interesting contributor to WebScale. They review pretty much every feature that goes in there and every patch that goes in there, despite not running WebScale in production. And the major concern with WebScale is that everybody there doesn't want to sign the Oracle Contributor License Agreement with the exception of Twitter. They have made it clear in public, probably last year, April, that they will give everything to Oracle if it was given under the Apache CCLA, but they just won't sign the regular CLA. And I hear lawyers are working on this, but we don't see any progress just yet. Percona will accept your bug reports. They will probably accept your payment for features, but they do not accept commits into their tree either. I think the other interesting way to get contributors is Google Summer of Code. And we ran this at MySQL for some time as well. And shortly after the, I'd say probably the Sun acquisition, Google had stopped giving us space in Summer of Code. And then again, MariaDB managed to get it in 2013. And it turns out that we've obviously improved the way development happens because we are shipping their code within a year, as opposed to not shipping. So a good example would be the per query variable settings that you see today in MySQL, Percona Server, WebScale SQL, and MariaDB. All of this basically came around the 5.6, 5.7 mark. But that feature was written by a Google Summer of Code student back in 2008, I think, or 9. So that student never saw his code shipping for a very, very, very long time. So a great way to grow the younger community would be through things like Summer of Code. And I guess the other good thing that we're seeing from Oracle is that they're also hiring a lot more younger developers. There are a lot of developers' names you can see in the bugs.mysql or the commits of people that I obviously have no idea who they are, and they're obviously new. That's really good. Now, when it comes to security, it's worth always generally watching for what is known as a critical patch update, and Oracle just released one probably 2 days ago. The real problem with critical patch updates is that Oracle is very obscure about their CVEs. They give you a CVE number saying that they'd fixed an unspecified vulnerability. This is a problem. So this then gets tagged. So when MariaDB reviews the changes, and Percona does this as well, one would have to go through the changes and then figure out which commit match which CVE and figure out what was actually being fixed. So it's a lot of extra work. And I guess this is what's making some distributions like Debian get annoyed lately. It's a lot of extra work, a little annoyed, yeah. So with MariaDB and Percona server, you don't have to wait for CPUs or the next release. Like if the security, if the security fix, warrants it being fixed in less than 48 hours, we inform the packages first, and then we make a release so that everyone is on board. And for one issue, I guess MariaDB was very quick to get patched. This is the one where if you tried up to 300 times, you would definitely get a root login to MySQL. It was an error with memcompare. So yeah, I think when it comes to security, this is something you need to think about as a DBA, as a user, because security matters, and making sure that things work out of the box and people can't crack you also matters. Another favorite question I get is MySQL dying? Frankly, no. I think it is actually at its most vibrant now. You should see the chats. Just yesterday, many people got their acceptance and rejection notices for the famous MySQL conference that happens in April. And there are people going on Facebook going, I wish I was there, why wasn't this talk accepted? I'm developing this on Alibaba's cloud, and it's running in production. Don't you think people would love to hear this talk? And I was going to have a 1-week holiday with my family, and now my plans are shattered. MySQL is far from dying. There were 400 talks being submitted. There are at least maybe 100 hackers working on MySQL, not working at Oracle. If we add the packages, and the Debian MySQL team does a wonderful job. I think they have maybe at least 8 or 9 active contributors. There's a huge chunk of people working on making MySQL better. I cannot imagine why people would actually say it's dying, or the ecosystem is dying. How many people here are not using MySQL anymore, or something in the ecosystem? See? Though you are in the MySQL track, so maybe I should have asked this somewhere else. So I think the external contributions, the people using it, the shared knowledge, and Oracle's actually, frankly, doing a pretty good job of running MySQL. I mean, they're making better and better MySQL releases, and you benefit. And when, say, MariaDB does something and Oracle does something similar in the next release, that means you benefit as well. And if WebScale does something today and you pressure Oracle to have such features, or you pressure MariaDB to have such features, again, you benefit. The ecosystem benefits by having many players. I mean, look at the Linux kernel, right, as an example. And if you think it's dying, oh, that looks pretty bad. If I could turn the lights off, which they said I couldn't do, then it would look much better. Anyway, for what you can't see in blue, you'll just trust my words and realize that they run MariaDB. For what you can't see in pink, they run some form of WebScale, or including their own trees. For those that you can see in white, they're most likely just running stock MySQL, which is brilliant. With the exception of Amazon. Amazon has got stock MySQL. They have got this thing called Aurora. They have got MariaDB. They've got lots of things, and they're not really stock. They have different backends and stuff. And for that one thing you can probably see in red, that one doesn't run MySQL, and I think you can probably guess why. It's a Microsoft service. So So that's the Alexa rankings of the global top 20 websites, and they're all powered by something in the MySQL ecosystem. Um, so really, like, I can't imagine why you think MySQL is dying and or dead. And people like, the Alibaba group, so you'll see Taobao there somewhere. They gave MariaDB multi-source replication, and multi-source replication went on to being used in production at Tumblr even, and so forth. And it didn't take much longer, I guess, from the 5.6 to the 5.7 release that now MySQL also has multi-source replication. So you can see features in one tree first, and today, like you see 5.7, there's wonderful JSON functionality, which you can see a vague release in the Facebook tree, and the MariaDB tree will probably get that in the 10.2 release. So I took a look at the people that actually do share stats, and I guess Popcorn is not the best way to actually track people, but in the absence of any statistics, we should just give you some vague stats that do exist. You'll actually realize that defaults matter tremendously. For example, MariaDB 10 has probably about 10% of the installed user base compared to MySQL 5.5 in Popcorn. And if I'm not mistaken, MySQL 5.6 has an even lower, around 2% install base. So there are more 10 users than there are 5.6 users, and that's largely because the default is MySQL 5.5. Ubuntu surprisingly has people using 5.1, I'm not sure why, followed by then 5.0. Someone's, it's an LTS release, okay. Okay, so I guess the Ubuntu LTS releases are really popular. I mean, the margin for 5.1 to 5.0 is huge. So I guess there's a lot of LTS users. And then you see people using 5.5 and then 5.6, and then you've got 10x less users of MariaDB and 4x less than MariaDB for Percona. So the numbers, you can go check them out at popcorn.debian.org or ubuntu.com, and you'll be able to see this yourself. But today you also get stats from things like the Docker Hub, the Juju Charms. They all export stats to you, so you can actually start gaining a better understanding of who's using what today. And that doesn't mean that we're talking about the top 1% of the websites out there, right? Like the Alexa top 20. OpenStack ran a user survey of about 1,300 users, and I was surprised because in the Galera cluster space, Percona actually B cluster came out first, and it generally used to have, I would say, way more users than MariaDB Galera cluster. But this survey suggests otherwise. So that's, I guess, good for us, but we don't know how many people are using this and so forth. So well worth taking a look at, and we have to rely on these user surveys because we don't really have feedback or update plugins. We do have a feedback plugin, but people don't turn it on. Also, I think this kind of survey will change the next time that the OpenStack user survey is run because, as I said, now that MySQL is investing heavily with NDB cluster and Docker containers and running all this in OpenStack and making it easier for people, the next time they run this survey, probably maybe this year in October or something, you may see a marked increase maybe in NDB cluster as well. This was October 2015, so the latest that I could get. They may have another survey before their next conference, I don't know. Okay, so yeah, you can get this from like openstack.org, public user survey report. And then you think further, like I've talked about like the other interesting companies, but there are also so many others like Yahoo, Yelp, Box, Dropbox, Booking, Pinterest. If you go to GitHub and you look for MySQL related utilities, you will actually be surprised as to the amount of utilities that are available today and the vibrancy around it. I mean, there is a great tool called Orchestrator that allows you to visualize your replication topologies, and that's being used at places like Etsy, Booking.com. It's written in Go by one chap, and it's amazing. So there are huge chunks of technology being developed for this ecosystem. So again, I cannot imagine why people are worried about MySQL overall. 5.7 has a whole bunch of interesting features. Some of them include turning on GTID online. There's obviously multi-source replication. There's GIS functionality, which I think is cool. JSON functionality. And there's a website called www.thecompleteListOfFeatures.com that will list them all out for you. Or you could read the wonderful manual. And truly, the MySQL manual is wonderful. Search is not so wonderful, but the manual is wonderful. I think there will be a 5.7 talk by Dave Stokes, right, Dave? Just JSON. You want it? Exactly. It'll take definitely more than an hour. So 5.7 is really rocking. So I suggest you check it out. Now I just picked on some of the features that MariaDB 10.1 still has that 5.7 doesn't. And MariaDB 10.1 is rocking, and we don't unfortunately have a MariaDB 10.1 talk, so you'll have to go to the knowledge base and take a look at it. Then there's Percona Server 5.6. And we're still going to eagerly await the release of 5.7, but there are cool things there like proxy protocol support, so you can use things like HA proxy, per query variable statements in a 5.6 release. The UDFs are great, fast index creation. WebScale. WebScale is interesting because there's a lot of hype around it. There are a lot of large orgs around it. But the funny thing about WebScale is, one, you don't actually get builds, production-ready builds from them, except from this one fairly small company called PSCE. I'm going to guess they're a bunch of ex-Percona consultants who formed this company. And they make production-ready builds for PSC, but I don't actually know if people are using them. But there have been some interesting changes, like you can specify in milliseconds as opposed to seconds the read, write, and connection and connect timeouts from the client side. There is also things like somewhat semi-implementation of an asynchronous MySQL client library, and the full implementation is in the Facebook tree. Super read-only to prevent writes by super users. This has also made it into 5.7. The option to add the InnoDB idle flush percent, so you can tune page flushing. So if the system is relatively idle, you don't flush so much, and you don't want to have unnecessary writes to expand the life of your flash. So some interesting changes as a base. And I believe that most of these merges are now being actually done by Laurenius at Percona, as opposed to being actually done by Facebook themselves, because the guy who was really into this decided he should move to another part of Facebook to make those cool Oculus VR things. Facebook has a wonderful, wonderful tree, and I highly recommend that you look at that tree. It has pretty horrible documentation, but every commit tends to equate to a feature, and in the commit message, you get pretty good understanding of what's going on. And something that just added recently was the option of max running queries and max waiting queries. So you can control the maximum number of running queries on the database and a maximum number of waiting queries as well. So if the wait limit is crossed, the queries will simply then fail. That is something you don't see in other shipping distributions. Facebook then created DocStore, and they spent a lot of time speaking to, I guess, the MySQL folk, who then implemented it in kind of a different way, and I'm not sure which one Facebook ends up picking. And for you to end up using it, I'll give you a hint. If you download the tree, you need to actually start the server up with -- allow document type equals 1, because otherwise it'll not work. Again, it goes back to very, very bad documentation. It's not really made for end users. It's made for Facebook. They also work heavily on RocksDB, and they also include MyRocks hot backup. Facebook is into RocksDB both from the MySQL side as well as the Mongo side. And I guess from the Mongo side, if you're interested, go download Percona's MongoDB server. The full asynchronous MySQL support and a whole bunch of other things. So again, I'd highly recommend you to check out the tree. I initially said that we're going to talk about Twitter, and Twitter has contributed features into the WebScale branch, including things like InnoDB flush, idle percent, which I talked about earlier. But I believe that when Jack Dorsey became the CEO, he fired a lot of people. He decided that open source wasn't so important anymore. They still do have MySQL engineers, but they haven't actually made any updates since about mid-June 2015. They, to the best of my knowledge, still run MySQL. They also made a project around called Apache Cotton for Mesos, so you could run MySQL in their clustered environment. And it turns out that I believe the Apache Cotton folk were also fired. So I don't know the status of these things, and I could not predict this when I submitted the talk because they were still employed then. So Ali SQL, this one's interesting, and there's not much documentation out there except for the fact that they work in private and they actually send features either to SCaLE and to MariaDB, but they're going to talk about this later in April, and also put the tree out there in public for you to use. And Ali SQL is what powers Aliyun, which is their cloud offering. So you guys here have this thing called Cyber Monday, yes? It's the Monday after Thanksgiving. Everybody goes crazy buying stuff online, right? So they have the same thing in China. It's called Singles Day. It's nothing to do with Thanksgiving. I guess if you're single, you buy stuff. Anyhow, they have these ideas that they have very hot SKUs, and they have made improvements that you can do inventory deductions on hot SKUs, and they're going to be sharing more about that soon. They've given stuff like logging shutdown information, as well as having persistent InnoDB auto increments. I've put an MDev there because that one is still being worked on. And they're also working on column level compression as opposed to just row-based. So a whole bunch of interesting things that are running in production for Alibaba's entire systems, as well as being offered to you via Aliyun. And Aliyun is possibly going to become something, as they decided to have another data center here in the US. So people are going to start using Aliyun. The non-server ecosystem is actually also quite expanded. You'd realize that MySQL is pushing amazing things there out. They've got router, fabric, group replication. You see that VMware picked up Continuant. Percona has obviously still got the toolkit, extra backup. SCaLE is out there. There's still things like MMM, several lines, cluster control, lots of interesting stuff. GNU Linux distributions, with the exception of Debian and Ubuntu, have mostly given you MariaDB. So beware, because when you ask for MySQL and go, hey, I'm trying to use this JSON stuff, wonder why it doesn't work. Well, it's probably because you're using MariaDB and not MySQL. So keep that in mind. I guess Debian is having discussions now. They're hotly talking about if they should drop MySQL or not, and I think they have precedent on doing this once with Elasticsearch, which is kind of scary because actually MySQL shouldn't be dropped. I think variety is a good thing, not a bad thing. So you obviously have the choice of MariaDB server and Percona server in Debian. And then we should talk about where are some of these folk now, right? So Drizzle is basically dead, and the large problem with that is because it was a single company open source project. So there should probably be a list of things that we should write down that you should evaluate before you actually back an open source project or product. And one of them is never ever go for a single company open source project. If the company decides they're not interested in developing it anymore, there goes your project. Most of them went to work on OpenStack. PBXT is actually doing relatively successful with this project called TeamDrive. It's like Dropbox, but used heavily in Germany amongst the media industry, but they're out of the engine business. Infobright, last I heard, was pivoting to make a Postgres engine. CalPond got bankrupt, so MariaDB Corporation picked up some of the assets, and Oracle picked up most of the crucial assets. And then Tokitech, Percona picked them up last April as well. And then there are a whole bunch of other dead engines or machines that had engines or optimized engines like Kickfire and Schooner, and all that went through acquisitions. As for the future, 5.8 is definitely being worked on. I suggest you take a look at the work logs, you follow the blogs. And look out for the interesting work behind cluster and group replication. Group replication's interesting feature that came out this week was it also runs on Windows. This is one bonus that over Galera cluster, because Galera cluster basically only runs on 64-bit Linux. Percona has said that they never aim to become a fork, and they will work extremely closely with Oracle. Look forward to their 5.7. They've made one alpha release, I guess. You can see the documentation of what's being ported from 5.6 as well. As a rough estimate, 5.6 for Percona server, I think, lagged about 8 months. I guess 5.7 will be a lot less than 8 months, but probably a lot quicker. MariaDB 10.2, there was a planning meeting last quarter, and it's still extremely available for you to join in and plan, but there will be things like window functions, common table expressions, making it 5.7 compatible. WebScale SQL has made it quite clear that they're going to skip MySQL 5.7, and they'll maybe backport interesting features, and then they will look at 5.8 closely. It's probably also worth noting that there are plenty of these cloud services available. Amazon now gives you MySQL in various versions, as well as MariaDB. Rackspace Cloud gives you MySQL, MariaDB server, and Percona server, and they have got 2 versions, including a high availability version. Google Cloud SQL gives you MySQL. There's Aliyun with MySQL and TokiDB. Whole bunch of others that are like PaaS players. Then there's some like Pivotal Cloud Foundry, which will sell you a MySQL PaaS, but if you look at the fine print, you're really getting MariaDB Galera Cluster 10. So, I don't know, you have to be really careful as to what MySQL actually means to vendors and you at the end. There are plenty of places to actually discuss this and follow development. And I think one of the better ones is planetmysql.com. Then the Maria developers and Maria discuss lists are pretty active. IRC, #Maria is pretty active, #MySQL is pretty active. Percona discussions list is very active on Google Groups, so you don't have to start a Launchpad account, which I hear is a bonus sometimes. MaxScale also has a group if you're interested in that. If you're interested in Galera, Codeship team is awesome. It's a pity that the internals list is kind of dead, and a lot of discussion is happening today on Facebook and Twitter of all places. Facebook being a completely walled garden, which is really hard for you to remember or search or figure out what was said before, because it was on someone's wall. And Twitter, because you have 140 characters, and how much discussion can you get there without most of it being snark? And if you are interested in Google's Vitesse, or should I say YouTube's Vitesse, which powers YouTube today, Vitesse's discussion list is also extremely lively. And it's also a Google group. When it comes to bugs, good old bugs in MySQL works. You do need a Launchpad account for Percona bugs. Then you need a Jira account for MariaDB bugs. And just to add to your fun, if you're following WebScale or the Facebook tree, you need a Fabricator login. So for this, it's preferred that you have either a Facebook account or a GitHub account. So you're starting to realize that keeping track of all of this is not as easy or one track as one would assume. It's no Bugzilla. You know, I could add the distributions as well, and that's actually quite hard as well, because they all have different ones. So, you know, bugs.debian.org and bugzilla.redhat.com are actually 2 of the better ones as well. And then there are all these conferences and events that have a dedicated MySQL track, and wow, I have 4 minutes left. You are actually at one of them. FOSDEM is the other one, which happens next week in Brussels. So if you like beer, get a flight. Then there's the Percona Live Data Performance Conference in Santa Clara in April. This one I highly recommend you to go if you're interested in MySQL, because this is the old MySQL Users Conference. Everyone goes there to learn new things. And then they have one in Europe. Oracle Open World is great. It's expensive, and it's not as big as I expected it to be, but it's a great place to go learn new things, and they have awesome concerts. I think Elton John and someone else played last year. It was a thrill. Then they have all these DB Tech showcases in Japan, so if you fancy visiting Japan at some stage, they have them every couple months. And if you like Buenos Aires, the stakes are huge. DataOps LATAM happens around November. Highly recommend it. These are all like MySQL focused. I don't know if you care about Gartner, but if you do, you'll realize that there's MariaDB, there's Percona, then there's Amazon Web Services and Oracle. If this sort of thing makes it different for you, you're more than welcome to read it. What should you use today? I think you really want to think about innovation that's happening today. Avoid vendor lock-in like the plague because you want freedom and you want vendor independence. You want to ensure you're well supported. Remember, you don't go for a company because they change their website every year. Think about it. That's not their product. There are plenty of support vendors. Some of them are here available for you. You can also look at funding, revenue, etc. Stonebreaker, famous guy in the database world, I'm sure all of you have heard of him, once said that for Facebook, using MySQL is a fate worse than death. So the nice folk at MySQL at Facebook decided to print that, and I took a photo. I reckon that mastering the ecosystem takes a lot of time because MySQL has been around for a long time, so there are lots of wide and varied solutions. Some good books that you may want to read: MySQL High Availability, I think it's the second edition. High Performance MySQL, great book, co-written by Peter, totally outdated. Peter, when are you updating it? Sometime, yeah. It's up to 5.5, so you need 5.6 and 5.7. And then there's Learning MySQL and MariaDB that may be interesting to you. A project that I'm currently working on is features.today. It's coming soon, so you can see all the features from all the varying trees. It's hard. And then a word from your sponsors. 2 minutes. MariaDB Corporation sponsored me to come here, so maybe visit them at booth 511. And apparently you can win a BB-8 Sphero, which costs $150. Like, I would never buy that toy, but if I got it for free, maybe. Yeah, and you can buy support, training, services, etc. So, with that, I'd like to say thank you very much for listening. You're more than welcome to check out the slides on SlideShare, which will be uploaded right after this talk. You're welcome to pop by the booth, and we have approximately less than a minute for questions while Peter can come up here and set up. So, any questions? Yes. There will be, I guess, once I upload it and then put it on the website. Yes, there will be a link. Any other questions? Well, thank you. Oh, yes. Regular expressions. Okay, well, all of them use standard regular expression library, except MariaDB, which uses the PCRE regular expression library. So I guess if you fancy PCRE, then MariaDB wins. It's also available in 10.0, by the way, and no, the others don't have it. Peter, are you planning to do PCRE regular expressions? No?
Oh, look at that. You like me to put me in a spot, right?
No.
Well, it's not on the roadmap yet, but we are following our customer's lead, right? So we'll see if that's reminder, if that's requirement, we can add it.
Yeah, so basically only 10.0 and 10.1 at the moment. Well, thank you for listening.
Okay, that's mine.
Apparently, I need to put it in your back pocket.
Oh, okay. Okay.
And then you need to stuff this over your face.
Oh, okay. I thought you just wanted to touch my butt.
This is not Russia.
Oh, okay. Oh, let's see how to get. Okay. So how do you get it out?
You just put it over your, yeah.
This way?
That is right. That is perfect.
Okay. Let me see. Hour.
And they are recording, so don't move anywhere. Just stand here.
Don't move. Okay.
And don't turn the lights off.
Don't turn the lights off, and don't joke, right? Okay. That's a camera out there.
No smiling, no blinking.
What are you putting out there?
So this is just the SCaLE.
Oh, okay. Okay. So you're not calling me names out there right now?
But yeah, this is
Okay. No, that's fine. That's fine. Okay. Do you guys hear me? And I see you can see my slides. That is wonderful. The only thing I'm missing is water, but okay. I guess we'll have to do without that. So we'll talk about MySQL sharding today. So anybody knows what sharding is here? Okay, some of you do, right? Anybody thinks sharding is painful? Oh, okay. That's good. So first, let me mention a few words about Percona and why really we are speaking about that. So we, as a company, focus on really helping our customers to succeed with MySQL and more recently InnoDB. We provide a whole bunch of services running from support to managed services, and we write a lot of software for MySQL. Colin has mentioned some, right? We have Percona server, Percona XDB cluster, as well as tools for backups, Percona Extra Backup, and Percona Toolkit. There are, I think, two things which are important about us. One is all our software is open source. We are not having some enterprise version which is closed source, or there is some other way to require you to pay if you want to use that. And we are also really vendor neutral. That is not our goal to really make you to use Percona software. That is our goal to, as a company, to really provide you the best solution for yourself. And frankly, that's maybe MySQL, that's maybe the Percona server, that's maybe MariaDB or Amazon RDS. If you're happy, we are happy. So let me start with a story when I talk about sharding. A couple of years back, a customer comes to me and say, "Oh my gosh, I read this all wonderful stories about Facebook, they're sharding, and there is a Dropbox sharding, and there is everybody in the world is sharding. So can you guys please advise me how to shard?" And I say, okay, let's look at your system first. And I would ask him, what exactly is your database size, right? Probably it's like, well, it's about 2 gigs in total. Interesting, right? Do you guys have a lot of traffic? Oh, actually, no, it's about 100 queries a second. Wow, maybe you guys just launched and you're planning to grow approximately 1,000 times in the next 3 months. Well, no, actually, we've been in business for about 5 years. We're growing about 7% a year, and we're expecting that for next year, right? Well, wonderful story, right? And well, the case in this case is obviously with such a small system. Oh, thank you. You don't really need to shard, right? Because even if the Moore's law is kind of kind of getting dead, right? We're still expecting performance improvements in the system much more than 7% a year, right? So the outcome for that is before you really decide how you're going to shard, you guys really need to decide wherever you need to shard at all, right? And I think that is a very important question, because if you guys go to different conference, read a lot of famous bloggers, a lot of them work for really large and famous companies, and they are often going to talk about how to operate MySQL on extreme scale. That may not be exactly your case, and in your case, the different principles may apply. Now, what is interesting is with modern technology, you can really go quite far without sharding, right? And I think with our semi-obsession with distributed systems in the recent years, we may forget how much you can actually get from a single, simple MySQL box, right? And let me throw out some numbers. From a single MySQL server, you can get more than 100K queries a second. You can get more than 100K rows updated or inserted, deleted per second. If you're going to some data kind of scanning queries, you can get probably more than 5 million rows in memory. MySQL can deal with 10K of concurrent connections, and if you are having some good box with a good storage and networking, you can actually have a 10 terabytes or so on the single MySQL instance, right? And this is not the marketing data, and it's not extreme, right? So if you the storage, that's one of the things which I hear a lot of people tell me, really? Do you really have anybody on the planet having 10 terabytes on the single MySQL instance? And I'll tell you, yes, I've seen many people doing that, and I have seen people up to about 50 terabytes on the single MySQL instance, right? That is kind of extreme, and I wouldn't quite go that way, but I think that gives you a good perspective. Now, guys, these are not some extreme marketing numbers, right? These are something what you can get from a pretty mid-range system, even in the cloud, right? And for a change, I'll show you some marketing numbers, right? So I stole that from Oracle. Where is Dave here, right? Dave, oh, he ran away. Anyway, so I hope nobody is watching. But anyway, this is the marketing slide, which is actually also true, right? But it is on a larger box with relatively simple query. But you can see we are getting well over 500,000 queries with MySQL 5.7 on the high end, right? So 100,000 queries is quite conservative. Now let's do some math, right? Let's say we have certain system and we are planning for maybe 3 million active users, and those users have 30 interactions per day, and with all our kind of world becoming kind of adjunctive and interactive, probably for single interaction you're going to have unlikely more than 10 queries, right? So with all this math and accounting for peak, for 3x between your night hours and kind of peak hours, right? We came to, oh shit, I was talking about wrong slide. Okay, anyway, that's the math I was talking about. Can you actually say shit on camera here? Oh, I did twice. Oh shit. Okay, anyway. So if you do this over math, right, what do we come out to? It is about 30,000 of queries a second, right? So really it is not a lot, even with those quite large numbers of users, interactions, and so on and so forth, right? So if you look at examples, well, the companies we worked with which avoided charging, that's quite range a lot, right? We had worked with pretty large enterprise household name here in US, but the more household name it is, the more they don't like you talking about them and naming them, right? I don't know why. But anyway, so those guys are using Drupal for everyday workflow for everybody of 200,000 employees, right? Can use Drupal, no sharding required. MySQL server loaded about, I think, 3% in average. Of course, they would use some replicas, right, for high availability purposes. But from performance alone, you don't need that. We also work with a number of e-commerce merchants, right? And some of them are selling well over $10 million per month, right? So that's a pretty serious e-commerce businesses don't need any kind of sharding. So, as you guys already told me at the start of this talk, is that sharding is a pain, right? Yes, well, and I know some of us like pain. Well, or maybe many of us like pain. I'm not quite sure what kind of this audience is, but, well, pain is not always good, right? Let's all agree on that. When it becomes too much pain, we still stop liking it, right? So, in a lot of cases, even if we sharding is pain, and in a lot of cases we want to either delay it or avoid it, right? So what kind of pains do sharding bring to us? Well, a lot of that has to do with complexity. Complexity for developers, right? Now I have to, instead of querying one system, I have to figure out where my data is. And again, even if it's sharding done automatically for you, if you're a good developer, you still have to think about that, because your query performance profile is going to really depend on the data distribution. There is more complexity from operational standpoint. There is more kind of complexity in technology because you have more bits and pieces. You have to deal with much more complicated failure scenarios compared to just single box essentially which works or doesn't, and much more complicated performance profile with bottleneck, the network involved in much more sense, and so on and so forth. Now MySQL sharding is frankly especially painful because compared to many other systems like MongoDB being a good example, MySQL sharding is very manual, right? MySQL came from an era when this kind of many servers operating together as a single entity was not really a thought, right? And it was afterthought. It was bolted on, right? And in many cases, it was bolted on by the users, right? Let's say Facebook would bolt on their own sharding, right, of Vitess, which you mentioned, YouTube, their own, right? There are guys like Oracle or MariaDB working on MySQL Fabric, MySQL Router, SCaLE. All those things have came much, much later, right? So if you can't avoid the sharding, you can often delay it, right? And why can't you avoid the sharding? Well, frankly, even though the modern systems became much, much more powerful and can handle a lot of beating for a single node, you can't build a Facebook on a single node, right? Or even a system which is probably 1% of a Facebook size. So, but in those cases, such systems are typically not born overnight, right? And it can take quite a while to get there, right? And you may not need to shard and waste a lot of your development and operational resources on dealing with that issues until you have much larger resources and much larger development and operational teams. So what few strategies do we have for avoiding the sharding, right, or delaying the sharding? And they go across those several dimensions, which is using architecture, functional partitioning, replication, cache and queuing, and using some what I will call supplemental technologies, right? Let's go through them one after another. So when you look at the architecture, we'll talk about a lot of architecture questions in other top areas as well. But what I think is one of the changes in the architecture recently was how people start to evolve to either microservices, each of owning kind of their own data, right? And maybe actually using different data store technologies, right? On the back. Or some people would call it not quite microservices, but service-oriented architecture. But in any cases, you essentially do have certain number of blocks rather than one monolith system, right? Which have different data stores, right? So the load and amount of data each of them have to store is different, right? So for example, you can say, hey, this is my interface which provide, let's say, user profile services, right? And this is maybe my billing system. If they live in a different, if they designed as different services, they probably don't have to live in the same database. Now, this also can be seen through another lens, which I call functional partitioning, right? And what that necessarily means is what we want to keep our separate data separate, right? Think about, I don't know, even such a basic side as a Percona, right? We have a lot of different bits and pieces out there, right? We have our blog, we have our Drupal-based website, we have you know, some other components. Really, each of them are quite independent, right? And they live on the separate databases to start with. I think it's important in this case to really maintain them to be independent and not accidentally mix them when you don't do that, because then if you need to scale and separate them on the different systems later on, that's maybe hard. To give you one of the simple practical advices is, if you have systems which operate in the outside on a different databases, give them different MySQL users with different permissions, which only have access to the databases they are designed to have access for, right? So that means, for example, if your main website needs an access to the content in Drupal, that wouldn't happen by accident. And then you say, oh, let me just move those to, let's say, blog and Drupal website on different systems. You have things broken down because there are some joins or anything else you didn't expect. Okay, replication, right? So anybody here use MySQL replication? Yes, well, I think the MySQL replication is probably by far the most popular strategy, both for MySQL high availability as well as for MySQL scaling, right? What replication allows us is to mainly scale reads. But what is a good thing is, in the web applications, reads are typically a very large portion of a workload, right? Majority of them for many applications. What you need to be aware about MySQL replication. What MySQL replication, built-in replication that is asynchronous, right? And don't let words trick you. Semi-synchronous replication is also asynchronous, right? So semi-synchronous is not synchronous, that is actually asynchronous with some better recovery properties. If you're looking for other MySQL replication options, I would consider Perconnect RDB cluster or other Galera-based solution. If you are the Amazon Cloud fan, the Amazon Aurora also does its own unique replication approach to MySQL. The next trick, which is very powerful, is using some sort of caching with MySQL, which also allows us to scale reads, right? So anybody used things like Memcache here, or Redis maybe for caching, right? Or if you guys have your application written in Java, you may actually cache it just in the application level, right? Not to go to a database all the time. Caching is really, really powerful, right? And I've seen applications which, through use of a caching alone, would able to reduce the traffic to MySQL by more than 95%, right? So that can be pretty cool. So MySQL have also built-in cache, query cache. But the thing what we know about the query cache in MySQL is what it sucks. I mean, it was designed in MySQL 4.0, right? It did not get any attention until now. It doesn't scale very well, both with many CPU cores as well as the large cache sizes, right? So if you have some like really bad applications, some really bad queries and low concurrency, you actually may benefit from MySQL query cache. But most high-end installations have to disable that. The interesting thing about the query cache, though, that is one of the things where Amazon Aurora seems to have implemented a number of changes. Amazon Aurora query cache is much better than MySQL query cache. And frankly, I believe a lot of the benchmarks published, that is really the cause, right? Just much better query cache. I mean, maybe this kind of a competition between the giants of Amazon and Oracle will make Oracle also interested to make some better query cache-like solution for MySQL too. Well, we spoke about application server cache, Memcache, and Redis. Two other things I think are quite important to know. One is you often can cache MySQL and MySQL itself. Building the summary tables for some very heavy queries, instead of running them all the time, right? You can call it like materialized views if you like, which are like glorified summary tables. Can be very powerful optimization techniques. Another thing which I know a lot of DBAs or database developers don't think about is things as HTTP cache, right? In a lot of cases, caching on HTTP level is absolutely the most powerful, right? Because frankly, the best way for to give your customer the best performance ever is if he doesn't even have to go from his system, right, to request to refresh an object. If it's cached right there in the browser memory, right, or the disk space, and you can often achieve that for a lot of data by implementing proper HTTP caching policies, right? So read on that. Queuing, that is another kind of big secret. If you look at that, any large-scale system out there does use some queuing, at least for some of the things, right? Because of many things, right? Queuing helps us to scale right for a variety of reasons, right? But it also allows us often to balance the spikes, right? Think about that. If I go ahead and something fun happens and I upload the spike of maybe 10x more YouTube videos, right, which needs to be transcoded than average, well, it would be overload the system trying to transcode them all at the same time in real time, right? By just putting them in the queue and then getting to them when you can get with your resources, right? Maybe doing some dynamic scalability on the background. That is much, much better architecture. And that also applies to a lot of the database things, right? Let's say if you build in something like Twitter and you have a lot of followers to deal with, it's much better idea not to try to put all of those notifications in real time, but put that to a queue, right? And then do whatever you have to do in the background. So there are a number of systems which we use for queuing. It's Rabbit, RabbitMQ, ActiveMQ. Redis is very popular. And what we see a lot, getting a lot of traction those days, especially for certain use cases, is Kafka. Anybody used Kafka here? Okay, well, great to see a fair amount of hands. Now, the other thing what I mentioned is use different technologies, right? Well, I hope that's not a secret for you, but the MySQL is not a silver bullet, right? Nothing else. And as much as it's great for certain things, it absolutely sucks for a lot of other things, right? And frankly, it's very interesting for me being involved in MySQL ecosystem for so many years to look back and say, well, let's say 8 years ago, we will do something like we'll try to write a Perl script which will go through, let's say, 10 slaves or 100 slaves, right? Run some queries in parallel and then aggregate those results of a group bys and all the other crazy stuff, right? And then what happened? Well, actually, we decided what those things are much better done on Hadoop and Spark, or Spark, right? When you need to crunch through a lot of data in parallel. Just don't do MySQL for that, right? I mean, it will be just pain and probably little gain. There are also technologies for full text search. MySQL 5.6, 5.7 have a full text search. Thankfully, it works with MariaDB now, right? So we don't have to pick between transactions or full text search abilities. But it's not really a scalable solution, right? It's what you can call like a low duty, right? If you're implementing search for home DVD collection, right, or something like that, if it's not overly large, you can use MySQL full text search, right? If you are building the search for many hundreds of gigabytes or terabytes of data, you will be much happy using Elasticsearch, Sphinx, Solr, right, or some other custom-made full text search technologies which do that in parallel. And you will be also able to have much more flexible search and much better search quality. There is also a selection of document stores you can use. There is also Cassandra, which we use for some very simple but very data store, but very scalable and reliable one. It has been amazing. The next thing to consider is what you actually want to consider optimizing your system before sharding, right? I don't know, I see a lot of people who are being kind of lazy, or we just like those kind of to go to a boss, ask for a lot of hardware, and then kind of play with distributed systems, and instead of just going and freaking tuning the indexes, right? I don't know why. But that is what we see the time and again. So what you can do, and you should do in terms of optimization. Hardware, think about getting fast CPUs, right? Especially because MySQL executes single query in one core. Don't buy into advertisement, oh, we'll give you CPU with 14 cores, but they all will be, less than 2 gigahertz, right, or something like that. For MySQL, that doesn't work well, right? MySQL likes faster cores, and for modern CPUs, you essentially want to look at the turbo boost frequency, right? Not the nominal one, because that is what your CPU is going to run at when you just run in one very, very heavy query, right? You want plenty of memory, because accessing the data in memory is much, much faster than going to disk. And guys, please understand, that happens even if you're using very fast storage. The fastest Fusion IO, right, or some NVMe storage is still going to be orders of magnitude slower than just going to a memory to fetch that 10 bytes you need from a field in the row. Fast flash storage, right? So solid state drives. I mean, for operational databases, you should not be running anything else, frankly. Anybody else is here suffering with spinning disks? Why? What? Oh, okay. Okay. Well, so I mean, I know in some cases we have some issues, right? With I don't know. It may be politics. It may be what somebody doesn't believe what SSDs can be reliable. 10 years later, right? It could be what they just spent all their storage budget for the next 10 years buying EMC for $10 million 5 years ago, right? Or some stuff like that. Well, but anyway, if you're being practical, you want flash storage. And you also want to have a good network, of course, right? A lot of a modern application when it comes to MySQL can be dominated by network through latency, right? Because I recently looked at, let's say, how much, if you look at the gigabit network, right, for example, often you will have, what's going to be round trip, right, in terms of in the data center. I think it's probably about 300 microseconds, right? Now, if you look at the MySQL, it can really process the simple queries typically in less than 40 microseconds, right? So if you think about that, simple selects or something, latency is going to be dominated by the network latency, at least at 1 gigabit networks, right? Another important thing about the networks is to think about the distance and number of hops. I have seen so many people making a mistake of placing MySQL server and app server very far, right, from each other, either distance-wise or just having a lot of a network equipment in between, which can add up a lot of latency, right? If you go through a few routers and so on and so forth, it's all adds up. Environment. Well, I probably would be preaching to the choir in this case, but I think that Linux is pretty good operation system to run MySQL, right? Would you agree with me, guys? Yeah. Right? Yeah. So and actually that is also the more popular ones, right? I think a lot of large-scale deployments are done on Linux these days, right? I see, I think a little bit more actually FreeBSD deployments, right, which start popping up over the last couple of years, but Linux is still absolutely dominating. New MySQL versions generally scale better, not surprised, but scale better with multiple connections, with many CPUs, with more complicated queries because of MariaDB optimizer. But for simple queries for a single thread, MySQL has actually becoming slower and slower over last releases, right? Last benchmarks I've seen, MySQL 5.7 is somewhere like 15% slower than MySQL 5.0 running single thread benchmark like SQL Bench. Right? You can look up, Mark Callaghan has wrote about that. MySQL 5.7, you guys heard about that. That's a pretty interesting GA release. I see there is a lot of still things kind of in flux. There are some changes implemented, right? So maybe I would not just rush and upgrade to 5.7 today, but wait the dust settle. But if you guys are starting with new development and plan to go in production in a few months, 5.7 is a great choice. And we are also working on a Percona server 5.7, which should be out sometime in February, and we have a release candidate available already, so you guys can check it out, give us some feedback. Configuration, right? Some people may disagree, but MySQL default configuration sucks. And it is by design, right? Because really MySQL was designed something like you install on your server, it sits out there in the corner, not taking a lot of resources. It's you know, can run some applications, right, and so on. So it was not designed as to go in and kind of take all the resources of a box, right, and not get anybody else to run. What that means is what you want to tune MySQL server, right? And here's a link to a webinar I did on this topic. It's not rocket science. Typically, you get like maybe 10 options you tune in MySQL, and you get it 95% where it needs to be, right, compared to defaults. Storage engine, right? When it comes to storage engine, InnoDB is default storage engine, and it is absolutely fantastic for a lot of workloads. In some cases, you may check out their TokuDB for high inserts, and if you want to get some much higher level of compressions than InnoDB, you can explore that. Anybody try TokuDB here? Okay, well, I see some hands. That's good to hear. IFN for sharding. So when do you want to shard? Well, here's a challenge we have, right? If you shard too early, we are likely to waste our resources because development and operations are going to be more complicated after we sharded, right? But if you shard too late, you can run into a wall, right? Because your application just unable to handle the performance required on that. So in this case, what I like to be thinking about is the term called architecture runway, right? Sharding is one of the architecture considerations you guys have, and think about this this way, and take it as a part of your architecture runway planning with all the other things you guys consider as a part of architecture thing, clean up technical debt, right? Other optimizations and so on and so forth. And what you need to understand in this case is how long it's going to take you to implement the sharding. Depending on your team pace, depending on your application complexity and so on and so forth, it may vary a lot, right? Like guys, I can honestly tell you, people have come to us, ask for sharding advice and tell me, oh, that's fine, we'll go ahead and implement over weekend. I'm saying, are you crazy? You're not going to implement over weekend. But they actually did, right? They would had the application simple enough, small, very agile team which will go and implement sharding or weekend in the application, right? In the other hand, I have seen some other legacy application which was written for 10 years, ton of queries, complexity. It may take a year or more really to implement the sharding, right? And I think that's important you make yourself an honest assessment and balance with your capacity, how much you guys can run on your current application, with how long it will take you to implement sharding, right? So that brings us to the capacity planning, right? So for us not to run into a wall, we need to know where that wall is, right? Make sense? So we want to figure out how we can do that, right? To understand that we want to do some estimates, maybe do some benchmarks. Be conservative, right, in this case, because it's much better to to predict a wall 20% lower, right, than 20% further down, right, and when you run into a wall and you're still not ready for your implementation. And one is very important thing is do not ever plan for linear scalability, right? So if you look in, let's say, at your system and saying, oh, well, currently I see only 10% of a CPU used. So that means I can handle 10x of query on this system. That is a very, very bad math, right? That's not going to happen for many reasons. Now, I have been kind of very critical of sharding, but are there any benefits of that, right? Well, and as if almost everything in this world, there are always like positives and negatives, right? If you look hard enough. So what are the positives for sharding? Well, one is sharding is really your road to the ultimate scalability, right? If you guys are building something Facebook scale, then you will need to shard sooner or later. And sharding may allow you to reduce some other complexities, right, or eliminate them. So for example, I have seen people saying, hey, you know what, yes, we do some caching, but we want to avoid having that extensively complicated caching level, right, with all those kind of invalidating cache properly, right? Our developers don't like that, it's complicated. Well, we just better bite the bullet once, we shard it, we'll have most of our data in MySQL memory, and accessing data in MySQL memory is pretty fast as well, right? You guys have seen the numbers of more than 500,000 a second. Asynchronous replication, that's another one, right? I've seen a number of customers saying, oh my gosh, our developers, they absolutely hate dealing with asynchronous replication because it has this property of, it works most of the time, right? I can go, in most cases, on my slave and get the data which will be reasonably accurate, but sometimes I get just some silly stale data. Developers don't like it a lot because there is no built-in guarantees in the replication about the data staleness which it will be to provide. So in many cases we see people just sharding when they say, hey, we read from masters, we write to masters. Our slaves are used for havability purposes and for some other applications, for example, some reporting. Because reporting, I know, reading a little bit stale data, not a big deal. Sharding also helps us to have better security and compliance, as well as possibly having the data closer to users. So for example, a lot of software as a service applications often would shard things to really separate the data between different customers, completely. Different customers live in a different MySQL instances, so even if developers do some mistakes, it's very hard for this data to intermix, right? And frankly, some of our customers may even require this kind of isolation as a part of that contract, so that is a benefit, right? Now, you guys also may hear some this sharding on the global scale, right? Some of you may have heard about those recent law changes, and as well as like political changes in the countries, where some countries may require you to keep the data for their users in that country. It's much easier to move to that kind of environment if you're sharded already, right? Makes sense? So often that will be kind of not purely technical consideration, but something beyond that. Now, costs may also be an important factor here. Right? Now, if you take a look at the majority, like managed hosting providers and the cloud providers, they really kind of want to take advantage of your pain, right? So what I mean by that is you would find what the margin, right, or how the cost escalates for very, very high powerful system is phenomenal, right? You can see high-end system being charged, 10x as a low-end system, even if you go to, I don't know, let's say the store to buy one, right? The difference in price will be only like 2x or so, right? So What that means in practice is what you often find if your cloud providers or, I mean, even if it's the systems you buy, the systems which have an optimal price-performance ratio, right? To give an example, you can get 4 socket systems with Intel CPUs, right? But those will be very, very expensive those days, right? They're much more expensive than two socket systems, even though they don't even give you like typically 2x of performance, right? So if we don't have to go for that the most expensive hardware, we can have a much more optimal system. And sharding allows us to pretty much pick the systems of any size. Because if you have implemented sharding well, you can shard over 10 systems or 20 systems, right? And that's really should not matter. And as I mentioned, that's especially important in the cloud because cloud may have a relatively lower instance size what you can get compared to a physical hardware you can buy, right, in terms of the top performance which is accessible in the cloud. So when do we shard, right, as a summary? Well, first is sharding can be a good idea when it's easy in your case. Some applications are easier to shard than others in both in development and operations. Second is when scaling up is impossible too expensive. I mentioned cloud, but enterprise can also have a silly politics, right? I remember the guys who had to shard because there was a MySQL DB8 team and the ops team, and the ops team believed that 16 gigabyte ought to be enough for everybody, right? And they would not provide them virtual instance with more than 16 gigs of memory, right? So they had to shard. Well, now you also may want to do that. Then your application is growing so fast, so sharding is imminent anyway, right? And in this case, you may want to invest your resource in sharding, which will give you, huge performance gains compared to some small optimizations trying to pick up 5% here and 10% there. So what are a few sharding questions we can talk about? Well, sharding level, key unit, how we handle havability, and sharding technology. Let's look at those in more details, and that will make sense. What is a sharding level? Well, there is 2 ways to think about that. One is you shard only on the MySQL level. Another, you kind of think at your sharding by deployment unit to a full stack level, right? Where you can say, hey, I take my MySQL and web service and the cache, right? And I shard all of that completely, right? Now, you often do the second one, for example, if you want to place those things in different regions, right? Or something like that. Or to get either better security isolation. And isolation at all, right? Because if you have essentially some very thin load balancer which kind of splits your customers to different pods, right, or whatever you want to call those nodes, then they're completely independent, right? And the failure affecting one of it is probably not going to impact everybody else, right? And you may have just, 5% of unhappy customers, which is much easier to deal with from all kind of things, right, including providing them a good customer service. Sharding keys. When you pick keys on the database for sharding, we consider a couple of things. One is when most accesses, right, simple accesses should go to a single shard, right? If most of your accesses hit all the shards, that is bad design, right? Now, no shard is large in terms of data size or load it generates, right? So, for example, sharding by country may be a good idea in the first one, right? Because most accesses for many applications will go to a single country, but then there are way too large countries, right, for most applications, and they're very disbalanced, right? I mean, you have a country like China or US with a ton of population, you have somebody like let's say Czech Republic, right, which is much smaller. Another thing to consider is when you shard, you don't have to pick one, right? In certain cases, for certain data access points, you may want to pick a couple of sharding keys and double store the data one way or another, right? So to give you examples, systems like Flickster, for example, right, which is a social network around movies. So it had two very different, but the most important data access pattern. Even through a movie, when you have all the comments and the vibe about a movie, or about you as a user, so what you have said and so on and so forth, right? So in such case, it would make sense to double store some of the data, which is very fast to access from one dimension or another, because, well, storage is cheap. Sharding unit. What do we do here? Do we shard by physical MySQL instance schema, or do we kind of shard it on a very logical level where you can have multiple shard objects placed in the same set of schemas and database? Well, it depends, right? Typically, if you are dealing with something like software as a service where you have, I don't know, let's say small number of customers which pay you lots of money, right? Maybe 1,000, 10,000, 100,000. You can actually even set up a small physical MySQL instances, especially those days with containers, right? You can, you know, run pretty large amount of them effectively. But if you have ton of users, something like a Facebook, then typically you end up having multiple kind of shard keys stored in the same set of tables or schemas. Another thing to consider, what is viability, right? Because the more servers you have, the more there is chance for one of them would fail, right? So pretty much, if you have rolled out the large sharding, you most likely will need to implement some of the some high availability scenario as well, right? And it even becomes more important than just single server, because if you just have a one single physical server, I've seen instances when people would have no downtime in many years, right? And they just rely on backups and it works for them. I mean, if you think about somebody like Facebook, right? They have many, or Google, they have many failures every day, right? Every hour even probably. So if technology doesn't compensate for that, that would be a disaster. So pretty much two common approaches to that. You can shard even over master-slave clusters, right, or the often referred, or use PXE or some other Galera-related technology. Let's look at some sharding approaches which exist those days. Roll your own, which is probably the most popular one, especially on the large scale, right? I mean, all those big guys typically have something very tied in with everything what they are doing. And in the MySQL world, it's heavily custom. VTES. VTES is actually, in my opinion, the open source technology is to watch, because I think it has been proven in production in YouTube. But those guys are very serious about making that into a open source project and putting a lot of very good documentation and so on and so forth, right? So I'm very excited to see what that would be. There are some other technologies like Jetpants and ShardQuery, which kind of exist out there in the open source, but they don't have nearly as supported momentum out there. Other things, Clustrix. This is proprietary technology which has a built-in MySQL compatible, has built-in sharding, right? From technological standpoint, it's actually quite interesting, but because it's kind of closed source, has a small community, I didn't see it having a lot of traction. MySQL cluster, that is another interesting technology which does a certain level of sharding automatically for you. Anybody runs MySQL cluster here? Okay. Anybody tried running MySQL cluster here? Okay, you guys know it, right? People who tried running MySQL cluster, there are much more of those when you're still running it, right? This is a rather complicated technologies, right, with a lot of kind of tricks. It's absolutely fantastic for certain workloads, right? But it's not as great for many other things. It's relatively complicated. And what I will also mention is there's actually had been a lot of interesting work done with MySQL cluster over the last couple of years or last 3 years. So if you gave it a look like 5 years ago, you may want to check it out again, right? But I would say also when you speak about MySQL cluster, it's kind of something which gives you like a medium level of sharding, right? Maybe if you need to shard and get, let's say, 10 nodes if all the data fits in memory, that may be the application for MySQL cluster. If you're doing the math and saying, oh, I will have 1,000 nodes in production, right, in a year or two, that is not nearly what MySQL cluster can support, right? And in this case, it's not going to be good enough. Few others. MySQL Fabric, that is a sharding effort by Oracle, which I think is interesting. And I don't know what I mean by interested in this case. I mean, I'm really would be interested to see it more in production. So far, there is a lot of a developer talk from Oracle about that, but I haven't seen it really deployed at a large scale. Tezor database virtualization engine, that was also pretty nice open source project. But as they kind of moved out as a company and focused on different things, I don't think it's being well maintained anymore. SCaLE has some rule-based sharding engine, which is also commercial. But I actually see a lot of SCaLE deployed, right? So that is a pretty common solution out there, especially by enterprise customers who don't mind using this kind of proprietary software. There was alternative to SCaLE here, SCaLE-base, right, which I keep here as a zombie on the slide as a reminder what a lot of proprietary technology companies may die, and kind of the technology we had can just disappear and stop being available. So, few things in summary, right? We guys can see what there are multiple technologies available for sharding. In the space of MySQL, unlike some others, there is no just standard way to shard, right? There is no some sharding solutions which 99% of the people are using out there, right? And we just can't follow. So you can see it as a downside, or you can see it as an opportunity to become creative. That's up to you. So if you guys are looking for sharding, what we as a Percona can do? Well, there is a lot we can do, right? We have both helped a number of companies to implement the sharding as well as supported them with sharded environments, either through support or managed services. And if you guys are very much interested to learn more about MySQL, MySQL is a kind of big part of your life, consider coming to Percona Live in Santa Clara in April. We'll have huge amount of MySQL content, and this year we'll also have content about a lot of other open source operational and analytical databases, right? MongoDB, Cassandra, and others. Well, that's it for me, and I will be happy to answer your questions.
I guess I hadn't seen PXC before, but when I looked it up, all the links point to Pacific Extreme Combat Mixed Martial Arts Club.
Oh, okay. Well,
PXC.
yes. Well, oh yes. Well, I mentioned that but I didn't clarify the abbreviation. So when I mentioned PXC, that is Percona XDB cluster. Yes, no, but that is a good catch, right? So is that actually what happened? You entered PXC and there is no PXC out there? Okay, can you send me a screenshot? I'll share it with our marketing, right? And tell me, how come, yeah? You can't even get us to the front page? Okay, any other questions? And if you want to troll me, that's fine, right? I mean. Okay.
Okay, so most sharding environments that I do come across, there never seems to be actually a good backup strategy for backing up the entire database because the database is just that big. Is it the general philosophy that you would never really ever back up a sharded database because you're assuming each shard is redundant?
Well, yeah, two things. First, let me put another plug, right? Actually, what I would be, one of the talks I'm very interested in at Fircona Live, where Facebook is going to talk about how they're doing backup at scale, right? And I think it's, for me, it would be very interesting to see what exactly strategies they deploy, right? Now, backups you need for sharding, right? And what I see a lot is people have some sort of a fuzzy backups, right? So, for example, say, hey, we take the shards and backups plus the backup binary logs, right? So if you ever need to restore the shard to a given point in time, approximately, they can do it, right? Having something like on a large sharding system, doing the kind of a global checkpoint, that is possible, but typically is quite is a bit painful, right? I mean, you can. I've seen people doing that by, for example, like pausing replication on all the slaves, right? So not to impact the master, then making some sort of note on the binary log position which corresponds to them and taking the consistent backup, right, for everything if consistency is needed. Now, another thing about the shards is consistency between the different shards, right, is typically a little bit loose. It's not like you have a foreign keys, right, and it's kind of absolutely going to be out there. So because of various failure scenarios, if there is a certain data consistency which has to be maintained between the shards, then it is good to have certain scripts to check it and fix it. Because data drift will happen, right? And you better have some tools to fix it. And that is what people can do, right? They can, well, in a worst case scenario, if something happens, I restore backup. Maybe it's not kind of exactly consistent with some other shard, right? But I can, I know where is my source of truth, right, for the data. Let's say this user lives on this shard, and then I go and check the things to ensure the relationships with other shards are consistent. Does that make sense?
Yeah, it makes sense.
Okay.
Will you answer my question as to whether it's considered industry average?
Well, I think it's you always have to be looking at what exactly problem you're solving. So because you can really get like 100% consistent backups, right, across, but that's going to cost you, right? And a lot of cases people just don't pay in those costs because again, among other things, like here's the thing, right? I think backups in general, if you think about backups in scenario there is redundancy and there is no redundancy, there are two different things, right? Because if I, let's say have my laptop, right, and I just lose my hard drive or something like this, right, then in a lot of cases I will have a full restore, right? And that is going to my use case. Now think about if there is a master and the slave which is constantly replicated. If I lose hard drive on this laptop, I will just fail over, right, to the slave. I don't do backup restore in this case. When does backup restore happens? Well, if you have some developer with dirty fingers, right? Anybody seen those? Right? Which kind of like, ruin some database. What happens in this case, though, is typically they trash one of the tables. Well, some developers are very gifted and will trash all your tables, right? But typically it's going to one of a few, right? So you have to restore the tables which were trashed, or even the data which was trashed, right? Which is a very different backup scenario, a restore scenario, right, than you may be thinking about, right? So that is why when you have a replication, often you have to optimize for how you can restore pieces of the data, right? And maybe kind of do partial binary log recovery, right, to catch up those pieces of data you restored, right? And fun stuff like that.
Okay.
Make sense?
Yeah.
Okay.
Have you had any experiences where one of your customers came to you and wanted to get rid of sharding? And if so, how did that go?
Well, I think, yes. In some cases, we will see that as a consolidation, right, possible. I think things have actually become a little bit better in this regard more recently with MariaDB, and now in MySQL 5.7 offer multi-source replication, which allows you to fund in replication. If you want to get all the stuff together, you may be able to do that. We also did some work with a tungsten a replicator to do that. But well, it is possible, but that's also, I would say, not totally easy, because in a lot of cases people would have created the IDs which are conflicting and so on and so forth, right? So that's going to depend a lot on the application, what exactly you're going to do. Well, yes, yeah, I think that is and I think in a lot of cases it's also a process of during the sharding, right? Is how do you, because when you speak undo the sharding, is that a consequence of a failed sharding project, what they implemented with sharding, and now that application version which supports sharding just blow up, right? And we want to go back. Or it was in production for 5 years, and then we say, hey, you know what, application is not growing, and you know, now hardware is so powerful we don't need sharding anymore, right? Those are two very different cases, because in the first case, we'll have to kind of temporarily maintain some scaffolding so we can always go back to unsharded system, right? Okay, any other questions? Mm-hmm. Well, I think it's, you know, I think it depends a lot on the scale, right? Linode is, I see, very well used on this on the kind of smaller scale. If you look for large scale resources, the AWS is probably the most popular one we see. We see some more of Rackspace, right? People who has been using Rackspace Managed Service started to use Rackspace Cloud a lot, right? They like the support approach and other goodies. So it has been varying, right? Google Cloud SQL also looks interesting, but I think, you know, when it comes to us, people really choose cloud for their databases, right? They choose cloud for their applications, and their database are going to live in that cloud, and that's what we have to deal with. Okay. Anything else? Yes, go ahead. Talk a little bit more about what? Balance in balancing the demand spikes. Oh, okay. So when I balancing the spikes, yes. So when I spoke about the spikes, right, is I was talking about the queuing, right? And here is an interesting thing, right? Is if you think about reads and writes, right? Which of those are really hard to deal with? A lot of people speak about writes, right? Writes are hard. It's kind of, you have to actually modify the data. But actually, reads are much more hard in many cases, because when you are doing reads, you have to get the user data right now, right? Until you have given that user the data, I mean, he doesn't get his value, right? When you're speaking about the writes, in a lot of cases, we can just put them in some sort of queue and apply later. And frankly, MySQL is already doing some of that for you, right? Think about what happens when you update the data in a DB table. It goes essentially in the queue like a log, right? And then it's going to be flashed from a buffer pool to the disk sometime later, right? If your log files are large, it's maybe much later, right? And that is essentially the idea for writes. So if you have some writes which are very expensive and you can afford certain delays, right? You put them in the queue and have some background worker to apply that at the given pace instead of slowing your all your users, right? So that I think is a main thing. Now, if you look at the other load management technique, which I would mention, is well, not all the features are created equal from a user value standpoint, right? So make sure you can disable them in the load spikes, right? If you can't bring up more capacity, right? Or if you don't have any other tools and toolbox. I remember for years, for example, you guys could see Wikipedia search sometimes being down, right? We're saying, hey guys, you know what, Wikipedia, you didn't donate us enough money, so we don't have enough servers, so search is not working, right? Come back later. But if you just use Google as a search, right, it still would be working and performing very, very fast, right? And I think that is very important to prioritize what a user experience, right? And not trying to make it kind of bad performance or a bad experience for all your users for all features, but better to have, you know, certain users to have a downtime, right, and certain features not work, and others to be like absolutely fantastic. Does that make sense in terms of load management? And what that means, by the way, right, is what you want to design the features so you can disable them easily, right, in production. So then feature becomes broken, right, or it creates too much unanticipated load, you can maybe disable that. And what's that? Well, yes, I think you're speaking about another interesting thing, right? When this is kind of a good development practices, right? If you're developing the large features on the scale, often gradual rollout is great, right? So you roll out feature for 5%, then you say, oh, it works, you know, gradually you roll out it for more, right? Well, yeah, absolutely. So it can be back and forth, right? It doesn't have to be black and white. Yes. Mm. Mhm. Well, I think that is a very good question, right? Because if you think about that, MySQL is not really great analytical database, right? In this case, I mean, it's because if you those days you have a lot of data, and if you want to analyze data, we want to have features typically, right? Being able to crunch a lot of data in a parallel, right, and use all the multi-core. So what we have in this case is some sort of an ETL process, right? And I mean, there is a lot of integration those days, right? You can use Scoop with MySQL to get the data in Hadoop. There is multiple tools right now how you can get from binary logs to Hadoop. You can use tungsten replication. There is, I know, some work how Kafka is being integrated right with MySQL, so you get some data out and then put it into whatever system you would like to do, right? So lots of choices those days. Yeah, and I would also mention what some people, right, we see who really love MySQL and they love pain, they can use multi-source replication to try to get it to one Frankenstein box, right, and try to run queries out there. Yes?
Can you touch on some more of the specifics of hardware that you prefer, let's say Opteron or
Well, Opteron is dead, right? If you haven't noticed, right? Unfortunately, with CPUs, we pretty much don't have a choice those days, right? I mean, in server-grade CPUs, Intel owns the market, right? We may have something to come out of it, power, or like ARM is kind of picking up ahead on the server, or there is RISC-V, right? But it's all probably like 5 years ahead. For now, you typically would look at the Xeons, right? And the choices you have is pretty much going to be defined by how many sockets you have, right, and how much memory you support. Because low-end Xeons would only support like 32, 64 gigs of RAM, right? Not enough, right? And then that is pretty much is main direction, what you're looking for. As I mentioned with MySQL, for most workloads, you want faster cores, not necessarily so many of them, right? But that again varies, right? In some cases, you may want a little bit more cores if your workload has enough concurrency. So that's what I would mention. Any other particulars you're looking for? Well, I would also mention a lot of memory, right? I mentioned for that. If your workload fits in memory, that's fantastic. And for solid-state drives, SATA and SAS are bad, right? Because that kind of bandwidth that SAS and SATA interface provide is just way too narrow. So you want to get some NVMe or other PCI Express based storage if you're looking for best performance.
So
Yeah, NVMe, right, or other PCI Express things, right? For example, Fusion IO is not quite NVMe because NVMe is kind of standard, but it's also very fast because it goes through PCI Express bus, not through some, funky interface which was designed for spinning disks. What's that? Well, for Flash, if you have a chance, avoid SAS and SATA drives, right? They're going to limit your bandwidth compared to PCI Express.
As far as sharding goes, how would you rate the differences between, say, MySQL 5.7 and MariaDB with Galera?
Well, I think this is kind of a little bit apple and oranges, right? If you look at in this case. So if you speak about the Galera, that is a replication technology, right? Wherever you in this case, right? And Galera doesn't necessarily help. It helps you in terms of that you have a little bit more predictable latency in replication, right? But still, you can't scale your write 10x, right, with Galera. Wherever it's you using one or another, you need to think about that, right? Also, a thing is, actually, I would say, because of how Galera works, right, often the limit of a data size per instance you would keep with Galera is smaller than for conventional MySQL. Right? I mean, I wouldn't go into, let's say, 10 terabytes Galera cluster because if you ever need to do SST, that's going to be very painful. Okay. Any other questions? Okay, guys, and I will hang out today and tomorrow at the Percona booth at Expo Hall. You know, if you want to stop by, please do. We should also have some toys out there, right? If you like to. Thank you.
Did Liz come out this conference?
What's that?
Liz?
No, Liz is not here.
Yeah, the battery level's great.
You go with your video?
Yeah, I think we're all good to go.
I'll be floating around, so checking on you.
Okay. Well, I also have an old Marine Corps command voice that I can revert to if I have. Well, folks, I'm going to do what they call in the restaurant industry a soft opening. I'm going to start a little bit before time. Once again, if you just walked in, and be warned, I throw these dolphins out for folks who ask questions and participate in the talk, and my aim is horrible, so if you really want to make sure you get one, come closer to the front. Yes, sir. Okay, that's a little better. And she wants it already. Whoops. Did it bounce the wrong way? Okay. For those of you who don't know me and haven't suffered through me in the past 6 years, my name is Dave Stokes. I'm a community manager for MySQL products, which means Oracle pays me to go around the world going to computer shows. And we do have an opening in the community management department, so talk to me over at booth 527 or 327 if you're interested. This is a talk. This is my third time giving it. The first time I did it in 25 minutes, which is pretty great for 57 slides. Did the same talk to the San Diego PHP group last Tuesday night and went over it much slower at about 2 hours. So hopefully I'll be closer to the first one than the second one. The slides are up at slideshare.net/DavidMStokes, or see me at the booth, or send me an email. My Twitter handle is Stoker. By the way, if you go past Twitters, for some folks, 2 years ago there was a Nicole Kidman movie called Stoker. So if you see stuff mentioning red hair and nudity, it's not me this time. So, MySQL 5.7, let me get rid of that resume slideshow thing up there. MySQL 5.7 has a lot of really neat features. If you made Colin Charles's talk earlier, he told you about the complete list of features.com, which covers all 150 some odd changes we made in 5.7. 5.7 came out in October. One of the more customer interested parts is the JSON data type. We have better security, better replication, group replication, where you update one master and it writes to the other masters. That happens at the server level, not at a floating layer above it. A whole bunch of other really neat features, but so far, the biggest interest I've seen so far is in the JSON data type. Now, for those of you who haven't been paying attention, JSON is JSON object notation. They picked the worst word possible by using object. That means different things to different programmers in different languages. If you saw the JSON talk yesterday by Christoph Pettis on how Postgres is doing their JSON, you'll see we do things just a little bit differently. And I'm sure as this becomes more and more of a feature in all the relational databases, because all the relational databases are adding this, things will shake out. Now, if you're really old-time Los Angelino, you might remember this. Interesting movie. It comes on Turner Classic Movies about twice a year. It's one of the last of the old Ray Harryhausen movies where they did stop-motion photography, and they actually had skeletons fighting with swords against an actor. You might notice that the skeletons have no muscle, so it's really an interesting movie if you can suspend disbelief. So what does JSON look like? Well, it has a key and a value. The value can be a number, it can be a string, it can be a real, it can be an array of strings, it can be just about everything. The JSON spec is rather loosey-goosey. I think it's 5 or 6 pages, and there's a lot of things they don't specify, which is great for programmers because they don't specify it. You're going to do it your own damn way anyway. So, how does all this work? Well, before we go into that, let me just say there's more than one way to skin a cat. If you've been programming long enough, you know that. The corollary is how many skinless cats do you want running around? In the old days, you could actually store JSON data in a MySQL database, going back to the earliest beginning. The trouble was you're going to store it as a character. In this case, we have a table that has an ID number and some data. And in that data, we shove in some JSON. Works. People have been doing it for a long time. Well, what's wrong with that? It's not sexy. It takes a bit to dig into that JSON data to get the stuff that you want. So we end up doing nasty things with regular expressions. How many of you really love regular expressions? Okay. Those who didn't raise your hands, stay away from these folks. The other problem you have is you're breaking the first rule of data normalization, which is what relational databases are built on. You cut up the data into the smallest usable bits, like zip codes, states, street addresses, first name, last name. With JSON, one of the problems is you're shoving everything into one bucket. Going through that bucket gets kind of nasty. Also, it's slow. If you're going to go through all that, they're going to do a full table scan. For those who aren't DBAs, that means you have to read everything in the book from first page to last page to go through it to make sure you got it all. Slow, inefficient, nasty. And once again, regex is just kind of ugh for most developers. So, with 5.7, we now have a JSON data type, like we have an integer or a real or a double or all sorts of character data types. When you deal with JSON documents, the default for everything is UTF-8 MB4. Once again, the default for everything is UTF-8 MB4. It's part of the spec. For those of you who are lucky enough to do only with good old USA Latin 1 data sets, no matter what you do, if you're doing it in JSON, it's going to store it in UTF-8 MB4. When you go to put in a JSON document into MySQL, it's going to make sure that it's a valid JSON document. If it's not valid, it's going to get kicked out. We'll come back to that a little bit later. When MySQL Server gets to your JSON document, it's going to put it in a binary format and sort some stuff out for easy searching. So if you're looking for something like the JSON data type in Postgres, where they just take everything as a straight dump, whatever you put in, exactly what you get out, not exactly what's going to happen here. Column limits. The size of your JSON document is going to be about 1 gigabyte. So if you're doing documents bigger than that, you're going to figure out a way to parse them up, cut them down, or do something with them. By the way, if you're on the server, the value for max allowed packet size is a system variable. You change it on your session, doesn't work on the server. So how does this work, Dave? Well, let's create a table called T1, have a column called JDoc, and it's going to be of type JSON. And into that document, we insert the values key1, value 1, key 2, value 2. And what does it look like when you call it out? You get key 1, value 1, key 2, value 2. Now, some are going to say, well, how efficient is this storage-wise? Well, in memory, it's going to take about 4.5% more space to put in all the overhead for the easy indexing of the JSON document. How many here really have to worry about disk space 100% of the time like we used to 30 years ago? Nobody. So you're the one guy. Okay. Facebook. Yeah. Now, something else that happens is when you put in a JSON document into MySQL and you're reusing the keys, remember it's a key value, a key and a value. If you repeat the key, you're going to lose the second and through nth one. It's going to take the first one. So here, we're doing a JSON object of key 1, value 1, key 2, value ABC, key 1, DEF. Two key 1s. Server's going to give you key 1 of value 1 and key 2 ABC. This key 1 DEF goes off into the bit bucket. This is part of the behind-the-scenes optimization. It also will internally sort those for the purpose of making lookup easier. So, let's say you want to look through a JSON string and get your value. Here's a case where we have a JSON string where ID is 14 and the name is Azatlan. And we're extracting whatever is in this string, that's what the $dot stands for, name. And it pulls up this, Azatlan. There's a couple other notations coming up that I'll explain. The trouble is basically when you're throwing a document into a column, we need special notation, special functions to dig down into that document and pull out the values. And as you see, it can get rather confusing, but it works fairly easily. So, the path syntax uses a leading dollar to represent the document that you're working on currently. Think of this in the PHP role as your this arrow, whatever object you're looking at. By the way, these slides, I know they're a wall of text, so please download them and go through them. I'm not going to read everything off of them to you. I can do it at the booth if you want. I know we're going to be limited for time. So here's an example with an array. Dollar refers to this entire array. So $0 evaluates to this over here. The string, the array starts with value 0, or count as 0. Value $1 is this here. $2 equals this. And there's no fourth argument, so value $3 gives you back a null if you're trying to pull that out. And because $1, $2 are non-scalar values, you could actually go through and dig down further. So 1 of A equals this, 1A1 equals that, and so forth. Have I lost anyone yet? Also, if you're coding stuff, you have a space in your key. Double check your work and put double quotes around it. Unquoted is not legal, it's going to kick out. In this example, we have a fish has a value of shark and a bird has a value of sparrow. The string .a fish will evaluate to that, to shark. You also have wildcards that you could use. So if you know that there's something out there like an address and it's going to be made up of various parts of an address string, you can just ask for address and it'll pull back the various parts of it if you have that separated in your JSON document. In recent versions of 5.7, you're going to see the column arrow path operator, which is going to be a synonym for JSON extract that I'll go into detail in a minute. The idea is putting JSON underscore extract in a lot of places was real cumbersome. Also, if you go back through some of the earlier blog posts on this, we were calling our functions JSN underscore whatever the function was. And it got kind of confusing for some folks, so we made them to JSON. So if you go to Planet MySQL and look for old JSON information, and you see the JSN, please expand it mentally to JSON. Right now, you can use the equal, less than or equal, greater than or equal, not equal, and a couple other operators. But right now, you can't use between, in, greatest, or least within JSON comparators. If you're doing order by and group by, be careful. SQL will order the null before everything else. So be careful there. Also, sometimes you're going to want to cast values. Here's an example where we're pulling out the ID field from a JSON document, and we want to return that as an unsigned. Just put that in your SQL statement, and you'll get what you want. Depends on your programming language and how you're handling it. But if you want to make sure, if you're an anal retentive programmer, which all programmers should be, cast it the way you want it. Functions. So since you were breaking the first rule of data normalization, and you basically have a file within a column, you need certain ways to go down and dig down into that information. So we have a whole slew of functions for you to use. Some of them are for creating JSON documents. Some are for searching. Some are a whole bunch for modifying. And a whole bunch to get JSON information, like how deep the document is, how many items are in there, and that sort of stuff. So, quick way to create an array. Select JSON array, pass it your values, and it'll create an array for you. JSON object. Here you can pass possibly empty string that will, and it will give you back things in a proper JSON format. Once again, if you put in invalid JSON into a JSON column, the server will kick it out. This is a good way to make sure that before you send it into the server that it's quoted properly. I'll talk a little bit later why, if you're a PHP programmer, and I need to delve in this for Python and a couple other languages, why you want to do this rather than use the native functions out there. Here's one where you're quoting null. How many folks here use nulls all the time in their data? Okay, so you folks are probably the old-time DBAs. Okay, we're not teaching that in schools anymore, unfortunately. Here's a function, JSON contains. This will return a 1 or 0 to indicate where the specific value is contained in the target document. So if you're looking for an address, you're searching someone's records, that's a JSON document, and you're looking for their zip code. If their zip code's in there with the target you're giving it, you'll get it back. Here's one that's similar. Indicate whether a JSON document at the given path or paths level has what you're looking for. Extract. This is how you're going to pull a value out. We'll go over this a little bit more in generated columns. I have a great example in there. So if this is kind of nebulous, don't worry, it'll soon be clear. Once again, remember the shortcut where we use the arrow operator. So here we're using the ID column within a column that's called C, where the value is equal to 4 to do an update. So if you're used to writing SQL, you have to get used to the arrow operator and do a few more coding, but it's nothing outrageous or massively changing in your SQL code. JSON keys will return the keys from the top level of a JSON object. If you're going down deeper, you have to do some tunneling. But if you want to go to the top level to find out the keys, here you go. Search returns the path to a given string in a JSON document. Returns null if any of this JSON doc, search, or path arguments are null or no path. And you can also do it where you can get the first one that comes up or all of them. So if your document has things that repeat, you can find them all. Array append, once it sounds like it does what it sounds like, it appends stuff to a JSON document. Okay, for modifying, you have insert, Here's some more information on insert. If a member is not present in an existing object, it will add it to it. If it is there, it will update it for you. Yes, ma'am?
Can you do similar commands in SQLite, or is it totally different?
I don't play enough with SQLite. I don't know if they have a JSON data type yet. I'll run into the guy who's the main guy for SQLite later this year, and I'll ask him then, but I don't know. I'm guessing they'll probably have one of these days soon. Merge. If you have two documents you need to put together, merge will do that for you. Remove. If you have something you need to get rid of, this is the way to do it. And replace. Find an existing value and change it in place. And also set. Now, some of you are going to ask, well, what's the difference between set, remove, update, and insert? Well, set replaces existing values and add non-existing values. Insert inserts values without replacing existing values, and replace replaces only existing values. You're probably going to use these functions most of all. What if you have something in JSON and you want to get it out of JSON? You can use JSON unquote. You can also embed all sorts of things like form feeds, tab characters, backslashes, UTF-8 Unicode values. Something else you might be wondering about, the depth of your document. How many items do you actually have in that document? How many keys do you have out there? Length, how many number of things you have out there. And remember, everything you're going to get back is going to be UTF-8 MB4. So if you're not used to playing with Unicode character sets, please be advised they do take up extra space. Before you throw something in the database, you might want to run it through JSON_valid to make sure that it is valid JSON. Once again, if it's not valid JSON, the server is going to kick it back. And if your program isn't designed to handle that properly, it's just going to frustrate you. Path syntax. Once again, remember $, is going to be the synonym for the document you're currently working on, which, if you're a DBA, translates to column. There are wildcards. Star represents the value of all members of an object, and a star within bracket equals the cells in an array. Simple, right? You got all that, you're going to pass the quiz when I give it to you in 5 minutes, right? This is going to take a little bit of working, even for folks who are long-time DBAs. Once again, we're breaking the first law of data normalization, so you have to go through these various hurdles to get to the data. How many of you are PHP programmers? Okay. I predominantly speak to PHP audiences, so I apologize if you're not a PHP coder, and I highly encourage you to become one. JSON by default, or PHP by default, has 4 functions. JSON, decode, encode, last error message, and last error. You saw the list that we have just to get to the data. These are the ones that PHP supplies by default. Simple example, taken right from the php.net manual. If you encode, JSON encode the array, it will give you a JSON doc. Only trouble is 70% of the time, it's okay when you're putting into MySQL. The other 30% of the time, no. So please go back and use the JSON quote function that I showed you earlier. Here's another example. For those of you who have never played with MySQL, this is a standard MySQL query. We're going out and pulling everything from a table called simple. Doesn't matter if it's JSON or not, you're going to get everything back from that table because you're using the star wildcard. So this part of the MySQL development process is not going to change for you. However, the insert will change. In this case, we have insert into table name values, and we're going to force it into a JSON array of 1, quoted ABC, null, and true. Once again, you got to make sure it's valid JSON or the server is going to kick it out. Yes, sir? 70% of the time, yeah. There are some things that just doesn't quote right at the wrong time. So I'm warning people, use the JSON quote function to make sure that MySQL is going to escape it the way you want. In engineering terms, they call it an impedance mismatch, where the person who built part A is expecting part B to work another way, and it doesn't quite do it. And unfortunately, this is the case in this point. So, one of the problems we have with the JSON data type is you cannot index that column with a normal SQL index. So, since we're breaking the first rule of database normalization, you just can't index all the junk in there. So we have an option called a generated column. Generated columns come in 2 types. Virtual, which means when you do the read, it goes out there and does the math that I'll show you in a minute to get the value you want, or stored, where it does the math and stores it into the table. It materializes that value into the data. So here's an example. We're creating a table called T1. It's going to have an integer field called F1 and an integer field called GC. And GC is going to be stored, which means it's going to be stored actually in the table. And GC is defined as the value of whatever F1 is plus 1. Example of using this is if you know your sales tax is 0.0625% and you're selling something and you want to put item price, sales price with tax in a table, this will generate it for you. So here we have a table called JEMP for JEmployee. We have a column that's JSON type. We have another one that's an integer type that we're calling G, and it's generated, which means it's going to be materialized and stored. And to get that value from this JSON document, we're going to pull out whatever the ID value is and store it in G. And then we're going to index that G. So if you need to go right to that ID number, it's there. Yes, sir?
Is that going to be used as a primary key?
It should be able to. I'll have to play with it. Usually it's going to be a secondary key. And MySQL, in this case, I'd have to look at it, but in this case it's going to do it as a secondary index, I believe. So when a secondary index is created on a virtual generated column, the values are materialized or actually written down in the table. And you can use the arrow operator as a shortcut. So, generated columns solve the problem of not being able to index the JSON document by itself. Another neat feature with generated columns, and there's a good example at the blog post here, if you need to do case-insensitive searches of last names or whatever, what you can do is, indexes on a column are always created with the collation of that column. So if you just index the last name, you're going to get that collation for the last name. Now, if you want, you can create a new generated column with the column's data, but stored in a case-insensitive collation. I'm saying this because I know somewhere in the next 6 weeks, one of you will have to do this, and hopefully the little kernel, there's a gentleman over here shaking his head, hopefully this will pop up. This is a neat trick. I've used it twice since this blog post has popped up. Syntax for generated columns. Column name, data type, virtual or stored. Remember for UTF-8 JSON data, we want to have it as stored. It's nullable, and you can actually set it as a primary key. So go back to that question. Right now, subqueries, variables, stored functions and UDFs, user-defined functions, are not supported. If you really, really, really need that, let me know. I have a couple engineers who would like to talk to you and use you as a test case. Also, auto-increment cannot be used in a generated column definition. So, all this is wonderful, but you're either on the JSON bandwagon or you're not. Is this the best thing since sliced bread, or is it just another XML? So, JSON's great, but once again, you're breaking the first rule of data normalization. This adds an extra layer of complexity, which means if you have a bunch of folks who don't deal with SQL and JSON documents in MySQL and regular thing, they're going to look at this and their eyes are going to roll back in the back of their head and they're going to go take a 3-hour coffee break. So you are adding extra layer of confusion. But what is it? What if you really need to store JSON formatted documents? Because that's the way everything's going. All the APIs are going JSON. This is the way to store it. It's easy, it's fast, and it goes with just about everything else you're used to doing with MySQL, and it's been available since October in MySQL 5.7. I had a gentleman at a talk in New York City, had this before lunch speaker slot, and he got very excited when we had the beta version of this code. And he immediately went home and took all the multiple listing service real estate data for the state of New Jersey that his company had, moved it out of Mongo, put it in this, and put it in production. Yeah. That's one of those things where it's beta software. Please go out and break it, but don't put it in production. Well, he did it, and it's been running solidly since last July. So you might find some holes, and please file a bug report review, but it is fairly solid. I haven't done any direct one-to-one Mongo MySQL 5.7 comparisons. It depends what you're doing. One of the things Mongo does is when you write a record, it adds some padding in there. So if you do a replace or an insert, they already have the space carved out. NODB doesn't do that. It wants to take that old record, part of the MVCC stuff, and give you a new one and keep the old one around in case you roll back. So in some cases, Mongo is going to be a little bit faster, and in other cases, we're going to be a little bit faster. And by the way, I apologize. I'm probably going to bonk you to get it to him. Whoop. Solomon, no questions?
Yeah, your friend who put that whole MLS directory in,
Yeah.
multiple listing services are always changing. Wouldn't half the houses have already been sold by the time he was a quarter of the way through?
I was hoping that he would have done a start transaction and an end and a commit at the end. I have no idea what he did.
It's a list of houses that are all on sale for any real estate, for the entire real estate community. And if you're entering in the entire database, chances are by the time if after the first day, some of those houses would have already been completed their selling.
Yeah.
What I'm saying.
Yeah. Yes, sir.
Two questions.
Okay.
One, since JSON has the concept of some primitive type like number and boolean,
Yeah.
does MySQL automatically recognize those and treat the data you extract, or it only treats it as string TF8?
I believe it's of a numeric value. I'd have to go back and read the man page explicitly. I believe if it's a numeric value, it's going to return you a numeric value. If it's a string value, it's going to return a string. But let me go back and come to the table, and we'll double check.
Second question is, can you compare JSON non-scalar values between comparators, or scalar to non-scalar, and if so, how do you handle that?
You should be able to do that with a simple cast. You know, cast something back as an integer and compare it to an integer. Yeah.
But in the slide, you just had, you can use comparison operators, and
Yeah.
so you would need to explicitly cast like an array in order to compare it to.
Or pull the items out of the array to pull there. Yeah. Yes, sir. Whoops.
Is there a limit on the maximum size of the JSON document going into JSON column?
Right now, it's about 1 gigabyte. Now, that's writing it out to disk and getting it solidified. While you're manipulating stuff in memory, if it's 1 gigabyte and you're pulling out 5K here and adding another 5K, it's going to actually be bigger in memory than 1 gigabyte. But once it gets written out into storage, it has to be no bigger than a gigabyte. Yes, sir.
I have some JSON data in a character field,
Uh-huh.
and I want to change that modify and say with JSON. It's going to go through and verify all of my records.
It should. Yeah. It's going to complain loudly about it. That's something I haven't done, and I need to do it my test. Yes, sir.
Can I just put array in JSON column and back into an allocation array?
Yeah.
It used to be columns and serialized array. Is that going to be
Well, it has internal indexes for the document retrieval of the various items, but it's not an index you can touch for your SQL code unless you use a generated index. So,
but it's not, it's different from the key value where the milk and key is.
yeah. Yeah. Think of the indexes within the JSON document as only for that document and over for the server to use. You can actually take advantage of piggybacking off that. It's for the server's use only. So, yes, sir. Yes. Part of the things with 5.7 was we increased it. I think, I have to go back and double check. It's been a month since I looked at it. I think we're up to 32 characters or 24 characters. I think it might be 32. We had so many people asking for it to increase it from the default 16 that we've done that. So, yes, ma'am, way back there. How many? Depends on how quickly you fill up that gigabyte of data. So if you're going to have one value, one key, one value, one key, one value, it's going to be up to you. So, yes, sir.
You mentioned not being able to do in between or in.
Yeah.
Can you still do group by and having?
Yes. You might want to play with extract to make sure that you're getting the exact values that you want from the thing. Yes, sir. How many data types in JSON? I'd have to go back and look at the spec, but they have all the normal things like numbers, strings, arrays, all that. It's very loosely typed. It's a simpler spec than the CSS spec, so it's kind of loosey-goosey. Yes, sir.
Do you have a wide JSON document? Is it better to use the internal MySQL functions to like insert or replaces, or is it better to extract the document and do it natively in PHP? Like, what's the difference?
You have a JSON document that's changed. Do you replace it with the functions that we provide, or you do it?
I
Or,
assume it's large, so you're right.
yeah. I'm not really sure. That's probably going to be more programmatic, how you're doing the data. I'm guessing if you want to do it in place with the functions that I just listed, it's going to be fairly simple. If you want to just pull out the entire thing, change it, then write it back, that might be a simpler process for you, but it's going to be your mileage may vary. So, yes, sir.
Are tables with the JSON data type designed to be single column with generated columns, or are they allowed to be,
You can do multi-columns, but it gets messy. All the quotes, commas, and brackets. It's designed to be easily human readable. And of course, once you give it to a human, the first thing they're going to do is try to obfuscate what they're doing. So, yes, but be warned, it gets messy. Yes, sir.
Any special consideration for using JSON keys in a join statement?
It shouldn't be. If you're using the generated columns, that's probably going to be the best way to do that. So, and I do that all the time. So, yes, sir.
Is there a reason why variables are not? Do you have that plan in future?
Variables within JSON docs? Well, unfortunately, that's not part of the JSON standard. JSON standard is kind of like, I won't say a final copy of the data, but it's all hard. It's nothing going to change on the fly. It's all determinate data. Oh, by the way, if you didn't get one of these, I have more swag at the booth, and the booth opens up at 2 o'clock. I have hats, I have some shirts, I have squeezable dolphins, I have boogie bots. If you don't have a boogie bot, you need to get a boogie bot. And I have some other, they're little wind-up dancing robots. So any,
Not those bags. No.
oh, here you go. Here you go, Solomon.
Yes.
For those who don't know, this is Solomon Chang. He's been around the MySQL universe forever and ever. He also likes plastic bags for some reason. But yeah. If you have any other questions, but you're too shy to talk in front of this group here of nice, friendly people, see me later. See me at the booth. I'm here till Sunday midday, at least. Yes, sir.
Having the data like you are just storing the data in a column, why can't you just text why you are going for JSON? Means you can store any data in the text column, right?
Yeah.
Why you are going JSON to this? What is the use?
Well, people just want to store stuff in JSON format. They don't want to break down the schema into its component parts. So there's a lot of folks out there who don't want to analyze their data or do anything, just want to throw it out there, which has its benefits in that you don't have to plan before. Problem is the speed's going to suck and it gets confusing.
Okay, so when you are creating the index, how will you work? For example, if I want to create a composite index on two columns, one is integer column and another one is JSON column. So if I'm creating composite index, will it work or not? How
Yeah.
it works?
If you're doing composite index, so like you have the zip code and something from a JSON document, you just create the index with the the column name and then the generated column name, and away you go. So yeah, you can do that. So any other questions about JSON or MySQL or? Yes, sir. Not yet. I'm on the road for the next month and a half, next month, and that's on my to-do list. Unfortunately, I was a JavaScript programmer a long, long time ago, and I've fallen off the wagon, and I need to get back into Node.js to figure out how this impacts this. But I can tell you with Python and PHP, this works beautifully. Yes, sir. I know the engineers are tweaking some stuff, but I really don't have enough information to give to you. If you have a feature you want, please propose it to us. We just came out with 5.7 in October, and we're on a roughly 24-month release cycle. So if there's something that we don't have and it's not on the drawing board, we can put it on the drawing board for 5.8. You may not actually see it come out in a test version for 6 to 7 months or a year, but if you are serious about it and can tell the engineers what you want, they will try to get it in there. Yes, sir.
This is more a statement than a question, but I guess I don't really see the JSON data type for MySQL, or I'm not feeling it, because if you're going to actually store keyed data, you might as well store it in tables with column names as those keys, and for every layer or level of arrays inside of that each JSON key, you're going to have a different table for that. I mean, I see it more as something that you would actually be converting relational table data into JSON rather than having a need to do it the other way around.
Yeah. There's a cartoon strip called Pickles. I don't know if you've ever seen it. The grandfather is showing his grandson an old rotary phone. And the kid sees the phone and goes, "Wonderful looking phone. How many pictures does it hold?" The thing is, you and I have gray hair. We're old dinosaurs. We want to break everything up and normalize it. A lot of folks don't want to do that, so they want to store stuff in JSON. So a lot of folks are doing APIs or they're doing audit trails. They're going to shove everything in JSON and be happy. So.
Hey,
Yeah. Yeah. But, yeah.
Does that make it less searchable from the
Well, anytime you break the rules of data normalization, things tend to bite you in the rear later. Like you'll hear people say, "Oh yeah, I pulled this column from this table and put it over here. 'Cause this way I only have to do one select." And then they never go back to the parent table and update stuff. So that's why your customers don't have the current phone number, but it's out here in the sales record, but it's not in the customer record. So when their credit card goes bad, you have no way to track them unless you know how to do that. If you're Sabre and you're doing 30 million transactions a minute, you're not going to do it with a JSON. You're going to do good old standard SQL. If you're a mom and pop real estate store or real estate shop or a store, this might work for some of your documents you need to store. It's just another option for you. So, yes, sir.
Curious how similar from the user's perspective it is to inclusion Postgres or potential service there. The place I see stuff like this used a lot is Rails is developing stored options hash, right?
Yeah.
It seems like a good fit. That's the kind of thing where you can use a standard and change across the
Yeah. That, an options hash where you're just throwing stuff you don't know about out there. But the dinosaurs like Solomon over here and myself are going to say, but damn it, you should have put that in your data spec.
So I'm just getting at is how standardized is this ability across SQL?
There is a standards committee, and things are kind of in flux, which means sometime in the near future, they'll probably come out with a recommendation and an RFC and a voting round. So 2 or 3 years from now, there might be something a little more solid, but right now you probably can't take our JSON and plug it into Postgres's or SQL servers, anyone else's. I'm hoping that in a couple of years, the entire NoSQL SQL stuff goes away, and it's going to be like the old ASCII EBCDIC wars. Ask him about that, Hill.
I'll ask you.
Yes, sir.
Any plans for allowing full text mixing with JSON?
Ooh, I haven't played with that yet. I don't see why you couldn't do that with a generated column. I'll have to play with that. That goes on the to-do list. And I'll blog about that. Yes, sir.
Not that you would ever execute it, just for hypothetical. As far as row width, I mean, if you have more than one JSON column, you have 1 gigabyte per column. Is there something with our width, like, oh, you can have 9 JSON columns?
I haven't played with that. I'm sure that, I know there's an upper limit for column storage, and I'd have to look that up and then backtrack from there. But yeah, there is going to be a wall that you hit. And of course, you never hit a wall gracefully. So, any other questions? Yes, sir.
I have another question related to performance. Actually, because our company we use Elasticsearch.
Uh-huh.
And I see the feature here that you added to this MySQL JSON document. Potentially, I think you guys probably can make, if you make it fast enough, probably can be a competitive to Elasticsearch as well. But right now, MySQL is not a good tool for documenting this type of
Yeah.
full text document search.
Well, the full text search isn't designed to be something like a Solar, Lucene, or Elasticsearch. It has its limits. It's kind of, you're looking for certain key phrases within a document. It's not as robust as Elasticsearch for the type of stuff you're doing. Will the JSON get there? Hopefully one of these days. But if you're doing a lot of corpus searches for certain keywords and stuff like that, this will work. What's real funny is we're doing a lot of work with MeCab processors for various different languages, non-Western languages, and doing searching for patterns. And a lot of that I think is going to be retrofitted back in. So I know the folks who are doing the Korean, Japanese, and Chinese pattern searches are finding some really interesting stuff, and it's beginning to filter back into the full text world. So hopefully with 5.8 you're going to see that vastly improved, but I don't think it's ever going to be something that's going to say, oh, everyone throw out Elasticsearch and go to this. So. Yeah, well, we're Uncle Larry Ellison, my big boss. Hopefully we'll get there one of these days, but it's not anytime soon. By the way, for those of you wondering how we're doing at Oracle, we're making money. We're the number 8 most popular class in all of Oracle. Our renewal rates for support are in amazing numbers, much higher than the industry standard. We're hiring. So if you have a resume and you want me to critique it and tell you how to get through the Oracle system, let me know. We're working on plans for 5.8, and there's some things we're looking at 5.8, which is, once again, 24-month release cycle. that may not make it in 5.8 will creep into 5.9. So we have plans that are 4, 5, 6 years out there. If you have suggestions, concerns, comments, or gripes, let us know. Always hit me if you have any concerns, comments, or gripes, or just odd questions. And once again, thank you all for coming out. Be sure to stop by the booth. I have lots of swag. And be sure to thank the volunteers who work here. So thank you all.
Hello, do you hear me? Yeah? Oh, at least this works. Okay. Thank you, guys. And sorry for the delay. Yeah, let's get started. My name is Alex Kuzminsky. I will be talking today about MySQL indexes. We were supposed to talk together with my colleague, but he had emergency data recovery work. So yeah, this is what we do in our normal life. So sorry for that too. This talk is about MySQL indexes. And you may wonder why another talk about MySQL indexes. But I'm glad you came. Probably have your reasons. But what I wanted to tell here is I wanted to explain give you some insights about how indexes in MySQL are built and how MySQL uses them to produce result of queries. And the point is, if you know that, if you can picture what's going on underneath, you can efficiently write queries straight away and make MySQL database more performant. So, I'm Alex Kuzminsky. I used to work a while ago as consultant in Percona, as well as my colleague. Now I'm MySQL SRE in Dropbox, and together with my colleague, we also run TwinDB that does data recovery, backups, disaster recovery, all that kind of work for MySQL. So here we go. I highly encourage you to ask questions. If I need to go somewhere in more details, feel free to ask. Although there is a Q&A in the end, so it's up to you. There are two big parts of this talk. In the first part, I will explain B+3 indexes, what it is, why this design was chosen for MySQL for InnoDB in 1994. And in the second part of the talk, I will illustrate you on SCaLE table how exactly MySQL executes different kind of queries, so you have better understanding what's going on. Okay? Yeah. Many times back in our consulting times, we've heard these stories when application hit limit of MySQL, and people were suggesting to migrate to something else. But after careful look, we found out that okay, you don't use MySQL right way, so you have to tweak something, and here you go. Database is performing much better now. So let's see how data is organized in MySQL. And I will be talking about InnoDB only. At some level it applies to MySQL, but in my opinion MySQL is not relevant now, so let's just drop it. The foundation of InnoDB data organization is B+3 structure. This is binary tree. This picture is from Wikipedia. Maybe it's familiar. This B+3 structure has multiple properties, features that were useful for data organization, and was good choice when InnoDB was designed. Key points here is that, as any other tree, it starts from the root, and the data is clustered together with key values in the leaf nodes of the tree. This tree is quite optimal for searches. Its speed is O logarithm n, and the same speed for insert and delete and update. So B+3. In B+3, all data is clustered together with keys in the leaf nodes. This is one of the reasons why InnoDB requires to define primary key, because primary key is the primary index, is exactly the data structure where InnoDB keeps the table. The difference from B+3, well, in InnoDB implementation of B+3 is a little bit different, and one of the differences is doubly linked list of nodes. In classic B+3, these are pointers to the next page, to the next leaf page. In InnoDB, there are this list is doubly linked, so InnoDB can perform optimally queries like order by ID and order by ID descending. So any order will work fine because of that. It's important that keys, these are primary key values, and inside the tree and inside each node, keys are sorted in the order. This is important for queries like range scan and so on. And we have first question, please, sir.
When we are storing data is already in a binary tree form, in the sense we have a root node, higher value goes to the right, lower value goes to the right, left.
Yeah, right.
And we are storing the data already in an ordered form. So the traversal is one direction.
Mm-hmm.
So what is, I'm just trying to understand what is the necessity to build double linked or use double linked?
Let's say you have query like select star from table, and you have order by ID descending. If you have descending order, you can access this node and get some value for the result, and you can output values in ascending order. But in case you want to do descending order, yeah, you need to have link to previous node.
Oh, I guess
So-
I just don't see the arrows pointing back.
Yes, this is to highlight the difference between classical B+3 and InnoDB implementation. Yeah, it's different indeed. And the B+3 has this property that for all leaf nodes, height is the same. That means that no matter where our key is, in the beginning of the table, in the end of the table, we can access value with a given number of searches. Okay. Yes, question.
When all the leaf nodes are of the same height, does that mean there won't be a necessity to rebuild the indexes for the sake of reducing the tree level?
Yes, and this is what happens when you insert new values, new records, or delete some records from the table. And yes, you have to rebalance tree because B+3 is balanced tree. But what is good about B+3 is you don't have to do that at every insert. because one leaf node actually contains many records, many rows, and you don't have to rebalance until the page is full. After it is full, you have to split the page and do rebalance, but that's optimal. I'd like also to know that B+3 was chosen for InnoDB when in 1994 when InnoDB started. It was time when we had spinning disks, and B+3 is good for those disks, to access data on those disks, because B+3 structure is very shallow. You have height is very small, even for large data sets, and if you need to read from table, it's all sequential access. This is what rotating disks are better in. Oops, sorry. Yeah, so we talked about reduced rebalancing. B+3 is efficient for range scans because we have all data in leaf nodes. Nodes are connected to each other, and when you do like full table scan or full index scan, it's sequential reads from the disk. And data is sorted by the key, and from that MySQL benefits as well for all kind of queries, like where you need to do sorting or where you do group by, etc. And I noticed there was a question somewhere there. Yes, please. I'm not sure I understood the question. What do you mean? This is just few of them, because if you compare B+3 with other data structures, to give you another example not covered here is, for some trees, insert speed changes, and the worst case and average case are different. For B+3, it's the same, which means you have predicted performance, which is good, because you can expect how to meet SLA, for example, for query response time. Okay. As I said, B+3s are very shallow, and that means that MySQL, to access leaf node, has to do less comparison. And to get to the leaf node, InnoDB has to do random lookups inside the tree. And because the height is shallow, height is small, we have to do them less. This is a formula to calculate exact height of the tree, and I would highlight here that, first of all, height grows slowly with a growing number of records. Another thing is, it's important to keep key as small as possible, because in that case we will have more keys in intermediate node. That means that our branching factor is higher, and that means that the height of tree is smaller, which is good, because the smaller tree, the less random lookups. And to illustrate the previous formula from the slide, I calculated height for some number of records. And here what happens. For 1 billion records, if your primary key is 4 bytes integer, height is only 3. That means that you have huge 1 billion records table, and to access any value, you have to do just 3 random lookups. This is very good. And to compare with longer primary keys, for example, some people use UUID. It's okay, but to understand implications of that, you can see that like on 1 million table, InnoDB would have to do 50% more random lookups. It may be critical if you are IO bound and you have to do a lot of disk reads. Make sense? So, and now I'm slowly going to the second part, and I will be explaining all access methods InnoDB uses based on this table. This is a table from SCaLE database, like reference table, and it has a primary key and 1 secondary key by last name. What it means? Oops. Yeah. So when you create this table, you get actor IBD file if InnoDB file per table is on. Inside this IBD file, you have 2 B+3 structures. One B+3 structure is index primary, and this is where you have all your data. You have key, which is actor ID, and all other fields are values of in this tree. First name, last name, and last update. There is a secondary key as well, and that means separate B+3 structure. And the key in that B+3 structure, in that index, is last name. And value is actor ID. So when you create the table, when you populate it with data, in the IBD file, you have these 2 structures. Okay, so, and based on this example, I will review all access patterns. And here I suggest a rule. If you can access data and produce result, well, if you can produce result while you're accessing data, then it will be fast. In other words, if you don't have to do any additional like temporary tables, additional sorting, if client requires a query result, and you can produce that result just accessing the indexes, it will be fast. Because in that case, you just spend the list of resources to produce the result. I hope it's not too confusing, and in the next slides I will illustrate this rule, so feel free to ask questions, and don't sleep on my talk, please. Okay. So the simplest case, point lookups. We need to get record by its primary key. Our actor ID is 3, and that happens very quickly because B+3 is fast. Its search speed is fast, and we can quickly search from the root node to the leaf node and get our record. Okay. um, if we need to do range scan, range query, that's also optimal, because see what happens. InnoDB finds a record with ID number 3, and it doesn't have to do additional lookups. It just reads all further records, and that will be the result of the query. We don't do any extra data processing. We just read records from the index and send it to the client. That's it. Let's see what happens when we query the table by the secondary index. Let's say we need to find all lns. You remember we have these two indexes. This is our primary index, this is our secondary index. We can quickly find records ln, key ln in the secondary index, and the value is primary key in the primary index. So if we need to output first name, last update, and to find that, we have to take actor ID, go to the primary index, find this record, is 118, and output it. The same for next record. We know actor ID 145, we find it, and we produce it. So see what happens. We quickly accessed the leaf node, we do range read, but we also do random lookups from the primary index. And sometimes that can make a huge difference, because if this table is huge, that will lead to a lot of random reads from the disk. Now let's see for what kind of queries we can use secondary index only. So we do it like in the most optimal way. One of the examples is when we do select count. If we need to count lns, we don't really need primary index, right? Because we have the data in the secondary index. We read from it and we can count it. That's it. And this is what called using index optimization. And if you run explain against this query, you will see that it shows using index. That means exactly that in order to produce the result, we just using secondary index, and that's it. We don't use primary index. This is what using index means. And this is very good optimization, because we avoid all random lookups from the primary index. Covering indexes, they help to use the same optimization. Let's say we have query like select first name where last name is Alan. If we have that old secondary index, we would have to do this additional primary key lookups, right? Because we need to know first name, and in the secondary index we have only actor ID. So we do a little trick. We created another index, secondary index, and we include first name in it. And although we do not include it in the where clause, we still benefit from it, because we can use this first name to produce the result of the query. And again, if you run explain, you will see this using index. This is good. So you sacrifice disk space because you need either bigger index or you need additional index, but you don't do random lookups, and that's good. You cannot use both indexes at the same time. So MySQL Optimizer will decide that, okay, I will use a secondary index on the last name to access data. And it will have to do random lookups to the primary index in order to get first name for each record. Secondary index on the first name will not be used at all here. I see. Yes, actually, you can benefit from that index. If you search for Kim Allen, you can use this index efficiently. If you have two indexes and you have the same query, like where last name is Allen and first name is Kim, then MySQL has to decide which index should it use. Because again, it cannot use like two indexes at the same time for the same query. So it will choose by index cardinality which index is more selective, and for more selective index it will use it to access the data. But then it will filter out all extra records where first name is not Kim. And you will see using where in that case. That means that MySQL has to do extra filtering out in order to remove all unnecessary records. Make sense? Let's go further. Another kind of queries that can benefit from secondary indexes, select distinct. If we need to find distinct, unique last names from the table, we can use secondary index for that. And yeah, it's very easy because we read many Allens, but we just throw them away until we find another last name. And because the records are sorted, keys are sorted, we know that we are not going to meet Allen anymore further. Make sense? Again, use an index. For group by, see what happens. If we have like a grouping function count, it's similar to previous query, but we do not output unique list of unique last names, but we also count them. We can also use secondary index for that because we read it, we do index scan, and while we read, we count them. And it can be max here or minimum or whatever, and it will still benefit from it. And what I like the most about this concept, this way of picturing indexes, how it works, how it accesses, is that you can understand if you do that, if you picture indexes in that form, you can even understand complex things like index lose scan. Yes, please, question. For maximum? So what? No, you will still benefit from it because see what happens. Max. Now I understood what you mean. Yeah, max what? If max actor ID, then yes. If something else, then no. Yeah, but if you have index like this, and you do last name max first name, it can use it, right? Because first name for any given last name, first name is sorted as well. So the last record will be maximum and the first record will be minimum. Yeah, but good catch, thanks. Yeah, so loose index scan, what it's all about. Let's add another column, rank, and let's fill with some values. So we have actors with their ranks. And now the question is, we build this index with last name and rank. And this is our primary key. So the question now is, let's find all losers, right? So we find records by their last name, and for any given last name, we find person with minimum rank. We can use secondary index for that. And this kind of optimization is called loose index scan, because see what happens. For any last name, we have to find value with minimum rank. So let's say Acroyd. Because fields are sorted like by last name and for every last name by rank, we know that for the first record of Acroyd, rank will be the minimum. So we know that this is our record from our result. And then MySQL can choose either to do range scan or do loose index scan, which means it will do another lookup for next key, and that helps to avoid large index scans. So you just read from the secondary index this row, and maybe some other row, and that's it. So you don't scan the index, you just pull some selected records. So this is loose index scan. MySQL benefits from indexes being sorted by their keys for queries like this. Let's say again you have this secondary index, and if you need to output all Acroyds ordered by rank, you can do it because you already have the order. Rank, the index is sorted by rank, and yeah, so you don't do additional sorting. Yes, sir. MySQL tries to, well, InnoDB tries to reduce impact. What you said is right. So when you update the rank, this index has to be rebuilt. And yeah, it can shuffle indexes. It can like change the tree. To reduce the impact from that, InnoDB uses index buffer pool. Index. Index buffer, yeah. Huh? No. InnoDB buffer pool is like whole thing where all I/O comes. Yeah, index. Insert buffer. Sorry. Yeah. insert buffer. But they changed it in 5.6. The name changed it to change buffer, because the same happens when you update records or delete records from the table. Secondary indexes has to be rebuilt as well. So yeah, it uses that change buffer to reduce random writes to the disk, because secondary indexes are pre-built in this change buffer and then flushed later on with in batches. It doesn't work for unique indexes though, because change buffer doesn't work for unique indexes, for unique secondary indexes, because you have to ensure uniqueness of the index. B+3 itself, it doesn't require uniqueness. Keys can repeat each other. Yeah, so it's like on top of B+3 feature. Right, and this slide can also illustrate you. Maybe you remember there were many devices that you have to put in the where clause, you have to put columns with more or less sign to the most right side. So let's say clause where x equals a and y more than b will use index, and if clause is x more than a and b and y equals b, is not gonna use index. Oops. Look at the index. If we had rank equals 40 and order by last name, can you use secondary index for that? No, you cannot. It's just doesn't make sense, because index is sorted by last name, and then for each last name, it's sorted by rank. So. Secondary indexes are... Question, please. Exactly. This is why you cannot do like percent value percent, because if you have index on that field, keys will be sorted. Let's say they are strings, and you miss the beginning of the string, so you cannot find record. You have to scan all of them. Yeah, so joining tables. In MySQL, tables are joined in a nested loop. So if you need to join 3 tables, MySQL takes one table for each record. It finds, for each record in the first table, it finds records in the second table that satisfy joining clause, and then for each record of the result, it searches for records from the third table. And to do these searches, MySQL uses secondary indexes, if it can. Yeah, but in this case, we want to output all movies with actors starring in them, and we want to order by title. And I'm not sure you see that, but this is the best what I could get in terms of formatting. The thing is, MySQL decided to take table actor, join it with table film actor, and then join film. And then the result, it will put in the temporary table and do additional sorting, because we need order by title. And the title is a column of film, not column of actor. So it has to do additional sorting. And remember that rule? This query breaks this rule because it has to do additional sorting. It cannot access the table. Oh my God. It cannot access the table and produce the result. But MySQL Optimizer decided to do so, most probably because it thinks that table actor is small, so not big deal. I will do additional sorting, but I will read less records. Let's force MySQL do what we want to do. And we know that title is the column of film. And we know that we will access records in the sorted order. So we will force MySQL to use this index by title to produce the result. And then for each title, we will join other tables, so it will give us the result. At least we will not do additional sorting. And yeah, it looks like it's worse, right? Because it has to read more records, but it doesn't do temporary table and doesn't do file sort. And yeah, response time of this query, by the way, you can easily reproduce this because SCaLE database is available, dataset is available. And I managed to reproduce this on 5.6, 20-something, 25. This query is 5 times slower than this query because we just used right to index, and MySQL Optimizer chose bad index and bad way to join tables. So yeah, you can check that by response time, but you also want to check handler counters. This is API between storage engine and MySQL server part, and yeah, if you run show status after the query, it will show you how many times, like handler read key, how many times MySQL asked storage engine to read key. So let's compare them. First of all, you see that in the first case, MySQL accessed indexes 20,000 times, and on top of that, it did some writes for select. This is because our temporary table. Yeah, in this case, it did only 12, 15, yeah, or 13,000 lookups. So 20, 13, no, 25, even 25. 20, 13 wins, right? And response time shows that. We optimized query took 5 times less time. And questions? Well, it's a big story with MySQL Optimizer. This is what they do, and both Oracle team and MariaDB team, they work hard to improve Optimizer, but in the end of the day, optimizer is stupid computer. And we humans, we know how we can access data the most optimal way. So yeah, well, optimizer is, we cannot exclude optimizer because MySQL has to decide how we access tables, right? So this is job of MySQL optimizer. Sometimes it makes mistakes. As you see, it makes mistakes only on, even on small tables, reference tables that were around for many years. Yet, well, this is life. Nothing is perfect. More questions? Yes, please. Mm-hmm.
So when I'm searching for one of the column, it will work as it will work as a root index. When I'm searching for second and third columns, it will not work.
Exactly.
So how I need to create a loose index? Any composite key will work as a loose index?
You have to understand that the index is not sorted by your second column. It's sorted for first column, and then for each value of the first column, it's sorted by the second column. So you're right. You cannot search by second column using that index because the index is not sorted by that column. What you can do, how you can work around that is you can have two indexes by each of them, and if you have query by first column, it will use first index. If you do query by second column, it will use second index. If you do or, like if first column is this or second column is this, MySQL can even do union. So it will get all records for the first part of the clause, get all records from the second index, merge the result, and merge the result and give it to you. So it can do. But what is important is in this talk, I believe, is to understand what's possible to do. Because if you know for sure that, okay, this is possible, then most probably it's implemented in MySQL. And if not, you can give a hint to MySQL optimizer, or you can file a bug. Hey, why this query is not optimal, even though I have these indexes?
When you explained about order by query, you are joining three tables and at last you are doing order by. So you are using fourth index for doing the order by column, right? So
Yes.
basically, index will use when you are joining the two tables on condition whatever you are giving column. Normally we used to create index on that on condition column also. Why? Because as it is joining the two columns, means the two tables, it will search for the index of the
Right.
So when you are giving the fourth index of order by column, you will not be able to use that on condition column, right? So how will it work?
You have to make sure that MySQL can still use the column. You have to define proper secondary indexes for that. Yeah. Yeah. Sometimes.
Say example, order by column also secondary index and joining column also secondary index. But I'm specifying like on mentioning, right? Fourth index of order by column. So joining the table on condition what table to use the index. Correct.
Yes. So you have to have indexes. So even though you force order join in order, MySQL still can use them, new indexes, because as you said, if you change order, some indexes may not be used. So you have to either create indexes or maybe change join in clause. So yeah, to join tables, you need to have secondary indexes anyway. Question, please?
Going back to buffers, I know for the join buffer,
Yeah, the thing is, it really doesn't make much sense to increase join buffer because of several reasons. First of all, if you access tables in not optimal way, you will end up with more I/O anyway. Another reason is if buffer pool is large enough, so your data set is in the buffer pool, then you don't need join buffer because data is in the memory already in the buffer pool. So yeah, well, I cannot remember cases when changing join buffer improves performance significantly. So I don't know, maybe in rare cases when you join large parts of the second table, it will help, but I'm not ready to give you example. Yeah, this is the danger with per session buffers, like sort buffer, join buffer, some other buffers. They are allocated per session. And if you have many sessions, multiply that amount by number of connections. And MySQL and InnoDB particularly, when it allocates memory, it doesn't check if it was allocated. So if you run out of memory, most probably MySQL will just crash, because at some point it will reference null pointer, and here you go, crash. Thank you. And one more question, please.
If you have a self-referential table,
Mm-hmm.
you're joining against it and aliasing it multiple times, can it use the foreign key index in addition to the primary key index? You know, essentially you're using the same table, but you're aliasing it, right?
Mm-hmm. Yes, you can. Yeah, if joining clause is right, it can use secondary index in the same table, then yes, why not?
So it's like a workaround to use more than one index on a table, perhaps, certain services.
I'm not sure what kind of
I'm just saying, as an edge case for fun to think about, if you think about the limitation of one query can use one index per table, right?
mm-hmm,
But if you're joining on the same table
mm-hmm.
using self-referential keys, it's a way to use multiple indexes.
Yeah, I wasn't 100% accurate when I said that query cannot use more than one index. That's not true. And I gave another example with index merge when for the same query MySQL uses two indexes, like to get part of the result from one index, to get part of the result from another index, and then merge the result. That's another example when MySQL can use multiple indexes to produce the result. Joining tables, again, you at least use three indexes to join three tables. If you join table to itself, exactly this is what happens. To join the table second time, you can use any index the table defines. So there are no limitations, including foreign key indexes, because foreign key forces to create secondary index. So yeah, effectively this is secondary index anyway. So yeah, you can use it. Thanks. Question?
Yeah, just a quick question. Is there like any kind of solution at this point for low cardinality columns?
For low cardinality columns, well, depends on situation, because even if index is not very selective, you can still apply limit optimization. For example, if you need just 10 men, right? So you have index by sex, and this is classical example of low cardinality index, but you just need 10. So it will access index, read 10 records, and will stop reading. So that query will be efficient, even though the index is not very selective, and yeah, there are many. Yeah, depends on situation, but general solution, I don't know. You have to be as specific as possible. Yeah, it will. Yeah, it will. Well, it's good to double check anyway, but this kind of situations it handles, and limit optimization is well known to MySQL optimizer, so it will probably use that low cardinality index to access the data. Any more questions? No. Okay, then thank you very much, guys, for the questions. Thanks.
All right. Can you hear me? Perfect. Can you see the slides? Because I can't. All right, so welcome to this session about scaling MySQL and MariaDB. I guess I have both here because the things I'm going to talk about apply pretty much equally well on both. But there are some differences, and when they come up, I will mention them. So, who of you all were here at Peter's talk this morning? Okay, not a whole lot. So Peter talked about sharding and when to shard and when not to. So this topic is very similar, except that I'll talk more about the technologies, how it's actually done with MySQL and or MariaDB, and not so much about the holistic pictures as Peter was talking about. So they do complement each other quite a bit. So a few words about myself. My name is Max. I'm from Finland and I live in the US. I live in Georgia. I don't have a southern accent yet, but maybe one day. And I work at MariaDB, so obviously I'm not totally objective in all of these things. And I used to work for MySQL back in the day as well. So I've been doing this for way too long. And yeah, I have no comments about this picture. It's a marketing team that put it here. So what we're going to talk about today is scaling or scalability. So I kind of looked it up in Wikipedia, and this is the phrase I found that kind of best described what we're doing or what we're talking about. So scalability is the ability of a system or network to handle a growing amount of work, and then in a capable manner. So I guess it means that we're able to, as load increases on our machines or on our system, we're able to cope with it in some form. And then what that is, it of course depends on your definition of scalability and what the limits are. Should you be able to cope with 5x of traffic without the user noticing anything, or do you have other constraints? So that's then up to the service provider to define what you need. It's a bit similar to high availability where the definition is pretty loose. It depends a lot on your requirements. Do you really need the system to always be the same and fully available and ready to be used at any point in time? Because typically, the harder your requirements, the more you have to pay. Well, some in money, but maybe not only money, but also time and admin work and so forth. And it's the same, of course, with scalability. The more you want to be able to scale, the more you have to invest in time, money, hardware, and so forth. Right. Then typically when we talk about scaling, we differ between horizontal and vertical, where horizontal just means you add more hardware to your machine, and vertical means you, sorry, the other way around. Vertical meaning you add more stuff to your machine, and horizontal just means you add more machines. And typically in the MySQL world, we've been doing a lot of horizontal scaling where we add more machines, and that's pretty much what I'm going to focus on here. It's a lot less interesting to just add stuff. But for those of you who were at Peter's talk, typically when you want to do horizontal scaling, it adds pain. Well, especially if you do sharding. But typically, when you add more nodes, it becomes more complex to manage. So adding more resources to one machine is typically a much easier solution. But it's less interesting, so that's why I'm not going to talk about it. So when do you typically need to scale? Well, to scale, especially in particular when we talk about horizontal scaling, of course, it's when the resources of your machine is not enough. And it could be that your data set is very large, so you have several terabytes of data, and well, performance is not as good when you have several terabytes. Like InnoDB is typically very good at scenarios where your memory size is same range as your data size. So if you have say 500 gigs of 256 gigs of memory and your data is about 300 gigs, InnoDB still performs pretty well, but when you start getting to 10x of data compared to your memory size, InnoDB's performance typically drops, right? So it has an impact on your performance. And then the question is, well, what performance degradation can you live with, and when do you need to do something? Right. So that's typically when you need to scale, and yeah, there's a few examples here of what that could be. So then when you look at what are the technologies available in MySQL and MariaDB, I'm going to talk a bit about doing sharding in a different layer than doing the sharding in the application and so forth, but the technologies available to do some kind of scaling are replication, which most of you probably know, Galera clustering, and then you go into these sharding technologies. And that's pretty much what I'm going to talk about here are these technologies. So let's start with replication. Who has used replication? All right. Actually, who has used MySQL or MariaDB? Okay, who hasn't? That's a better question. Who hasn't? Okay, everyone has used. Good, you're in the right talk then. So replication. Most of you has used replication, right? So the replication was added to MySQL a long time ago, 15 years ago almost. So it's been there for quite a while. It's been, upgraded a bit, changed a bit throughout the years, but kind of the basic technology is the same. You have a master. Everything you ever write or every query that changes data is logged in a binary log, and then you have slaves that are connected, and they basically ship these log events to their own relay logs, and then they implement these changes as well, right? So it's an architecture that's totally slave-driven. The master doesn't enforce the slaves to do anything. The slaves basically connect, and they keep track of their own, what they're doing, and so forth. But from a scaling point of view, what's interesting here is that, first of all, this is not synchronous, right? So the slaves are never, well, there's no way of guaranteeing that a slave is in sync with a master. So basically, you don't know. There's a delay. It might be large, it might be small, but it's kind of undefined. And the second thing to notice is that all nodes have to perform all writes, right? So if you do an update on the master, every single slave will also do the same update. So you cannot scale writes with replication because every node will have to do every write. So replication can only be used for read scaling. Right. And there are, interesting. So that's kind of the basics. So if you look at the phases of replication, it's basically 3 phases. You have or for the standard replication, there's when you commit your transaction, it's at the same time it's written to the binary log on the master. This is actually optional. You can do this in 2 phases, but let's say if you care about your data integrity, you don't want to have it optional. You want to have it in 1 phase. There's an option called sync bin log in MySQL. Who knows that option? No one. So sync bin log is the option that actually forces MySQL to synchronize your binary log events with your commits. If this option is not enabled, your binary log is not necessarily synchronized with your transaction log, which means that if your master crashes, you might have transactions in the binary log that were actually never implemented on the master. So, if you care about your data integrity, you should always have this sync bin log on. I'm wondering if the default has changed. Colin, do you know? What? It's on now. It's 5.6 or 5.7. So before 5.7, by default, it's off. So by default, your binary log and your transaction log are not synchronized. Right, so that's phase 1, and then phase 2 is shipping the changes to your slave, and then phase 3 is applying the changes on your slave. So it's a 3-phase, I guess. Well, so it's the redo log. I'm talking about the redo log on InnoDB, which is the crash log. I mean, this is not a problem if your master never crashes, but if your master crashes, your binary log and your read log might not be synchronized, which means that you have a problem. Or, I mean, your data is not the same, basically. If you're using something else than InnoDB, well, typically you already have a problem then. So like if you use MyISAM, there's no integrity already on the table level, so it doesn't make a difference anymore. All right, and then so that's replication. It's asynchronous. There's a thing called semi-sync replication, which basically ensures that one slave has received the changes. So basically, this phase 1 and 2 are made one phase. So when you commit on the master, it will wait for a slave to acknowledge that the slave has received these changes. So it adds basically a small weight here, but it doesn't change the nature of replication at all. Right, so what about using replication for scaling? So you can use replication for scaling. It was actually originally developed for scaling. So replication exists in MySQL for scaling because MySQL used to be used heavily on websites. And typically on websites you have a lot more reads than you have writes. And that's why we developed replication. We had a customer who asked for this feature to be able to scale its read traffic. So the idea is that when you have a replication like this, you direct all your writes to the master, but the reads can go to any of the slaves. Now, the problem here is that the slaves are not necessarily in sync, right? So you don't necessarily read the latest data. So you need to have an application where this is possible. So, for example, if you store blogs and it might not be so important that every user gets the latest comments to each and every blog. So there you can easily read from the slaves, and if there's a delay, there's a delay. But let's say you're dealing with monetary transactions there, you don't want to have delays. You don't want someone to see that their account has more money than it has or something like that. So that's good. So I calculated some numbers with regards to using replication for read scaling. So if you have an application where your read-write ratio is 95% reads, and if you then add 4 slaves, so you have and you compare that to having just one machine, basically your load goes down to 24% of having just one machine. So it's a fairly good distribution. You went from 100% on one machine to 24% on each machine by adding four slaves. But now the read-write ratio on each machine has dropped to 80%. So if you now add more slaves, you don't get the same benefit anymore because the read-write ratio is heavier. So basically, replication will incrementally decrease in value as you add more nodes per node. And if you start with something like 50% read-write ratio and you add 4 slaves, you still have 60% load on each machine because you can't scale the writes. So here the benefit is much, much less. And then, well, after doing this, you're at 16% read, so it's useless to add anything more after that anymore. So from a scaling point of view, replication is great if you have a lot of reads. If you don't, it doesn't help, pretty much. Then you can use replication for other things like having a hot standby or something like that, but for scaling it doesn't help. Yeah. No, it goes down for all of them. Well, because the slaves have to apply all the rights. So that's the problem basically. And now it's not one-to-one because so in the beginning what you shipped was the actual transaction. So in the binary log, if someone says insert this, you would ship insert this and you will re-execute the statement. So it's actually exactly the same on the slave as on the master. But now there's a row-based format for the binary log. So it's row operations, so it's not statements anymore, so it's not exactly the same operation on the slave, but in time, the difference is very small. So you still have to execute every single operation on the slaves. So that's the problem. All right, so that's kind of replication. Any other questions? Yeah.
What's the ratio when you would recommend against replication based on the read-write?
I mean, 50 is definitely, I would say, you gain so little by adding machines, so you probably pay more. You probably want to look into some others. I mean, first doing some kind of vertical scaling on them, trying to get as much as you can out of the one box, and then after that you have to look at sharding options, which is basically some kind of sharding is the only way you can scale writes, pretty much. So I mean, I think it depends. It depends on your use case, but 50. But then and again, you can use the slave for other things as well. So you can use, if you have 2 slaves, if you also use them as a backup or something, then it makes more sense as well. Right, but one thing, of course, is also to add it here that when you have this, so you need to have a proxy, or somehow your application needs to be aware of the setup, right? Because you need to be able to direct all the writes to the master and all the reads to the slave. So either you have a middle layer or your application is aware of the underlying topology. And that's kind of the same with Galera cluster. Who here has used Galera cluster? Okay, only a couple of guys. Okay, who has heard of Galera cluster? Yeah, they mentioned it every talk. Well, many of the talks today have talked about it too, right? So Galera is the underlying technology, and you can get it in Percona XDB cluster or MariaDB Galera cluster. And it's basically a clustering technology where nodes are kept in sync. So when you commit a transaction, before it's actually committed locally, it's certified by all nodes in the cluster, and they at the same time implement the transaction as well. So you basically get a cluster with all nodes in sync. So it's it's mainly an HA technology. It's there so that you could have several copies of the data. And the main difference between replication, besides that it's built into InnoDB, so it's below InnoDB, so it doesn't use the binary log anymore. It uses a WSRep library that basically has the Paxos communication. But the main difference is that it's synchronous replication. So you don't have to worry about slave lag, or there are options you can choose so that slave lag doesn't happen. So basically your slave will always be in the same state as the master. And that also means that from a cluster point of view, there is no master. All nodes are equal in a Galera cluster. So you can write to any node and you can read from any node. But similarly to replication, every node has all of the data, so every node will have to write everything. So again, you don't really get any write scaling, really. Right. So same thing as with standard replication, it can be used for read scaling, because now if you have 3 copies of the data, you can read the data from any of them. The difference is that you can actually use this for reading any kind of data. You don't have to worry about the slave lag anymore. Now, you can actually get a bit of write scaling from Galera just because you can relax some of the, I guess, requirements of your disk, because you don't have to worry about durability on a single node, because you have durability across the cluster. So you don't have to care about making sure that the read log is always committed on a specific node, because the transaction, as long as you commit your transaction, it's already in the cluster, so it exists in one node. So you can do small optimizations like that, but it doesn't provide true write scaling. So it doesn't work for write scaling, but it can give you some benefits, because you can relax some of the durability requirements that you normally have locally, because you now have multiple nodes. But same thing as with replication, you typically need some kind of load balancer in front of Galera to make this work. All right, any questions about how Galera works? I mean, I explained it, but very quickly. Mainly HA technology, but it can be used for read scaling. So if we then look at adding a load balancer, because both replication and Galera clustering, they don't provide a load balancer by themselves, so you need to put something in front of it, which could be the application. Your application could be aware of this, but typically you don't want to have it in the application, because you want to be able to change the underlying topology for your data cluster or anything without having to change the application every time. So what if you add more nodes? What if you remove nodes? Do you have to change the application? So typically you want the middle layer that takes care of this. And here's a list of proxies or similar technology that you can use. I'm going to show a few slides about MaxScale, partly because it's our product, so of course marketing, and partly because it's fairly good as well. But again, I'm not objective in this, right? So MaxScale is a proxy we built, which is, you know, it has great features and it's very modular and all these things. But from this point of view, the main positive features with MaxScale is that it's a proxy that's built specifically for MySQL and MariaDB, right? So it has built-in monitoring that's specific to the replication and Galera technologies. And one thing we have in MaxScale is that we have a thing called read-write splitter or read-write split router, which basically allows you to not have to worry about splitting reads from writes in the application, but MaxScale does it for you. So basically, if you have a cluster or a replication setting, you have a master and you have slaves, all you have to do is send your queries to MaxScale, and MaxScale will then, based on whether it's a write or a read, it will either send it to the master or send it to the slaves. So that's something that's great because you don't have to do it in the application. And MaxScale also monitors all of the servers, so it basically checks that the servers are there, but it also checks for replication. It checks the lag, how far behind are they, and you can create a rule saying, all right, I don't want to use a slave who's too much behind. And then because MaxScale monitors this, MaxScale will just stop sending queries to a slave if it lags too far behind. So MaxScale works with both. So MaxScale is just a proxy, right? But it actually has built-in functionality for both. So this is the replication part. You can also use it with the Galera. And here it's the same. It monitors the state of the servers, because in Galera, the servers can be up, but not synced with the cluster. Because so if a server crashes in Galera, a node, it comes back up, then it needs to synchronize itself from another node. So it can be there but not synced, and basically MaxScale monitors the state of the Galera servers or Galera nodes and only sends queries to the ones that are there. So these are kind of the benefits for having a proxy, is that the application doesn't have to think about all these things because this proxy does it for you, right? And MaxScale is fully open source and it's on GitHub, wherever it is. Actually, an interesting thing with MaxScale though, so when you use MaxScale with Galera, you can use it and do just round robin, send queries to a node. But one of the potential drawbacks with the way Galera is architected is the fact that you can have deadlocks upon commit. So I spoke a bit about how Galera works when you send transactions to Galera. So basically, all of the transactions processing is local. So when you send a transaction to Galera, it does everything locally, and only when you do commit is it sent over the network, right? So that's great because it means that you don't have any network hops like in between your operations. But the drawback is that you might have changed the same row in a different node at the same time. So you might have a conflict. And I guess the good news is that Galera is aware of this, and Galera will detect it, and Galera has a conflict resolution, which is basically to roll back the transaction. So when you press commit, you might get an error saying transaction rolled back due to conflict, right? And then you have to redo your transaction or do something else. But this only happens if you write to all nodes, and also only if you write to the same row at the same time. But an easy way to avoid is by just directing all writes to one node, because you don't really gain anything from writing to multiple nodes, because every node still has a write everything. So you can actually combine Galera cluster with the read-write split router and just write to one node. Now, this node doesn't become a master. It's just a master because we say so. It doesn't have you can switch master at any point in time, and it doesn't affect anything, right? But here, by using the read-write splitter, you basically avoid all that. You cannot have any potential deadlocks or conflicts between the different nodes, because you only send writes to one node. So everything is handled locally. If there's a conflict, it's handled by local locks and not by aborted transactions. So that's also a good use case for MaxScale. Yeah, so that's a good question, but because Galera is still a synchronous cluster, it doesn't matter. So if your transaction is committed here, it's also committed on the others because they're still in sync. So you send your transaction here, you press commit, and if you get OK, it means that it's also on the other server. So then if this one crashes, you just use another one, and it's already synced. You don't have to do any failover like you do with replication. If your master crashes, you might want to promote one of the slaves to become the new master, but then all of the other slaves have to fail over to the new master. So you have a failover process. In Galera, you don't have that because they're all in sync all the time. So there's no failover process. Can you scale max scale? You mean can you have multiple max scales? Yeah, so the answer is yes. I guess the problem is that they don't communicate. So there wouldn't be any communication between the different max scales, but you can have multiple max scales to the same underlying database cluster, yes. But there's no, if the max scale crashes, you basically have to start all of those sessions over. There's no session recovery at the moment. Yeah, so you can have some kind of virtual IP between two max scales or something. That's just for HA, but it doesn't really scale for scaling purposes. But for HA, you can have two max scales running. One crashes, you use the other one, but all the open connections on the crashing max scale are lost. All right, so that's basically what you can do for read scaling, replication or Galera clustering. Yeah. It's totally different. It's totally different. I'll get to MySQL cluster actually in a moment, because MySQL cluster is based on sharding, so it's completely different. And Galera cluster, every node has all of the data, so it's great. It's more like what you normally would think a cluster is, whereas what used to be called MySQL cluster, which is, by the way, the worst product name in the history of MySQL, because no one ever understood what it actually was. I used to be part of the team who was implementing and selling MySQL cluster, so we always had to explain what it actually was. Yeah, so Galera cluster, because I mean, as soon as you you have multiple versions across the database, and you don't have a central system. So if you have a shared nothing architecture, the problem is always how do you distinct network failures from node failures? And typically, there's no good way of doing it. You don't know, the other node is not communicating. You don't know if it's because you can't connect or because he's not running. I mean, there's no way of doing that. So Galera uses basically a majority vote, basically. So that's why you need 3 nodes, because if you have only 2 nodes and they can't communicate, both will stop because neither has majority. You can actually in Galera you can have an external arbitrator node, but then it means you still have to use a third machine, so you might as well make it a cluster of 3, and then you're good. So 3 nodes is kind of the minimum, and I mean 80% of our customers, maybe 90 even, use 3 nodes. I've seen a few with larger. Yeah. Yeah, that's a good point as well for load, to be able to scale the load, of course. If your nodes start being if you have 2 nodes and it's above 50%, the one node can't cope with all of the traffic anymore. That's a good point. All right, so that's kind of for read scaling, but if your problems is write, you need to scale the writes. None of these replication or Galera helps you solve that, because every node has to do all of the writes. So then you have to go into sharding, which means you have to somehow partition your database across multiple instances. And how you do it, well, you know, this is kind of a high overview of different things you can do. So kind of the best way to do it, in a sense, is to do it in the application logic. Have some kind of clear way of dividing your data or dividing your use cases so that you can use different servers for different parts of your application. So if you somehow can do it in application, that's typically the best way to do it, because then you also control exactly how you shard it. But in some cases, you just can't do it like this. You have one big table, and basically you need it to be one big table, for example. And there, I mean, if you shard in the application or lower down, it doesn't really matter, because you still need to be able to put the results together from queries in this big table, for example. So there are some connectors that offer sharding functionality, like the connector J, or together with MySQL Fabric, it works. You can do it in the proxy level. So, for example, SCaLE, which I talked about, it actually has like some very primitive schema-based sharding. So if you are able to, if you have like the same schema but different schemas, basically, it can shard so that each server will only have one of the schemas, but it looks like the server has all of them from the application point of view. But then, if you have the case, as I mentioned, of the one big table, this of course doesn't help either, because you need to be able to split the table, the one table, into multiple pieces. And you can't use external tools for that, like SCaLE or something. But there are also some storage engines that offer sharding built into the storage engine, like NDB, which is MySQL cluster. I prefer calling it NDB because then it's less confusing to what it is. Or Spider and some others. So actually, Peter kept on mentioning this, so sharding equals pain, right? So there's a lot of reasons why you shouldn't shard. There's a lot of disadvantages with sharding. Your queries become more complex. If you want to be able to like aggregate the data together, you typically can't do it in one query unless you use a sharding technology that's on the storage engine level, like Spider or NDB. But if you use any higher level, you can't get the results. If you shard on the application level, well, you basically, there's no query that can give you a result across all the shards, because you have to do it in the application layer. So you're not able to solve your problems with SQL. It's harder to manage because you have multiple servers. It's not high availability, of course, is much harder because you need to make sure that every node is highly available, and backups were also mentioned, and if you want to do backups and things, you have to somehow manage that they're all synchronized as well from a data integrity point of view. If you do a query that touches multiple shards and one shard crashes in this operation, how do you now make sure that there's not 3 shards that has the change and 1 shard that doesn't have the change and things like that? So you have to somehow deal with those kinds of things as well. So pretty much everything becomes more complex when you shard. So I mean, Peter had a 50-minute talk about sharding, and he basically, all he talked about was how not to shard. So because of this, right? So I mean, and he has good points, right? But I'm not going to go into that. If you want to know more about this, look at Peter's talk. So just looking at where you can shard, I talked about this. You can do application, you can do proxy, or below the database, because there are storage engines that provide sharding. So someone asked a question about the MySQL cluster, or NDB. An NDB is basically a sharded storage engine. It's originally it was actually a key value store, a sharded key value store. So basically, in NDB you have the MySQL servers or MariaDB servers up here, and the lower level has basically a sharded key value store, and then you have functionality for getting values. Now, and basically NDB has a built-in sharding. It's based on the a mod of a hash value of the primary key. So you have a table with a primary key. By definition, it's sharded, and it's all based on a hash of your primary key, and you can't change it and so forth. So you can't basically start MySQL cluster without sharding. And it also had built-in HA and all that kind of stuff. So it's fairly fancy, but so who here has used MySQL cluster or NDB? A couple of guys. So was it easy to use? No, exactly. It's a lot of trouble. We had customers who tried using it, and it typically for a generic OLTP use case, there's a lot of drawbacks, a lot of things. Well, many of them are just because it's sharded, because you can't do the same things with sharded. But because we provided a full SQL interface, people would try to do like joins and aggregations and things like that. And because everything was sharded, it took a really long time to build these queries, right? I remember a use case where we had a customer who had a fairly small table. It was a 10 gigs or something, not even, no, it was less than that. It was like, whatever, 2 gig table. They put it in MySQL cluster. That was the big table, then they had a few small tables. And they put it all in MySQL cluster. I think we had 4 nodes. We did a query, it was a join. It took 8 hours, right, to get the results. So then, because it was only a couple of gigs a table, it was a 4 gigs or 3 gigs, whatever it was, and some other tables were smaller, so we put everything on a InnoDB, on a local server, and it came back in 7 seconds. So 8 hours or 7 seconds, right? Yeah, so first of all, at the time, MySQL didn't have any other joins but nested loop joins, right? So which means that you do, it's like a for loops, right? So you start by saying, okay, give me the first row of the first table, and then, all right, first row of the second table. And every single time you do this, you do a network hop, because it's distributed on a network. So if you have a table with a few billion rows, you have to do a few billion network hops. And this is for every table within your join. You're joining 7 tables, you know, the latency times a few billion, and it starts showing. So it's all latency, right? It wasn't processing. None of the machines was running on high CPU load. It was all network hops. So that's kind of the problem with sharding. Now, some of these issues have been solved with cluster. It's not as bad anymore, but it's still, you can't do complex queries as efficiently if you shard, right? It's just out of the question. Right, so that was NDB. I'm not going to talk so much about NDB. We get customer calls. It's like, hey, we have this MySQL cluster. We have data on it. We got it running 4 years ago. No one has touched it. Can you help us get rid of it, right? Because no one remembers any commands anymore, and it just runs, right? So we still get this, but typically it's customers who want to figure out how to get rid of it because no one knows how it works anymore. But I guess MySQL Oracle gets more of these than us. So another thing I wanted to mention as sharding technology is Spider. Has anyone heard of Spider? No one? All right, so Spider is built into MariaDB. So if you download MariaDB, you actually get Spider there. It looks like a storage engine, but it's actually not really a storage engine. It's kind of an overhead, I guess, to storing the data. So what Spider does is that it uses the partitioning interface. Who knows that MySQL or MariaDB has partitioning? No one? One guy? Okay. So there's a syntax for doing partition by, and then you decide how you want your table to be divided into different partition. It could be based on a date value or lists or whatever. You basically decide you want to split your table up into smaller pieces. And that's been in MySQL since 5.1. So what Spider does is that it allows you to use this partitioning syntax, but instead of having local pieces of the table, you actually put them on remote servers. So the Spider, I guess, node won't store any data, but it will basically be a relay to where data is actually stored. So this allows you to very easily, I mean, from a syntactical point of view, very easily split up the table, and you decide completely how it's split up because you say partition by, and then you use any of the built-in partitioning mechanism, and then Spider basically takes care of distributing the data. Now, Spider is not, I guess, an enterprise grade feature. You have to do a lot of these things manually. So, for example, you have to make sure that these tables exist on the other nodes. You can't do resharding easily. It has to be done manually and so forth. So there's a lot of things that could be improved with Spider, but still the basic concept works, and most of all, it provides right scalability. Because now if I have this Spider table here, I've split a table up into 3 based on just different customer values. So now if I send a write query to the Spider node, it won't do anything. It will just relay the query to where it actually should go. So with this setup, I could do 3 times as many inserts per second as I could with just one node. Or I could store 3 times as much data, or I mean both, technically. Of course, there's a small overhead of having the Spider node, but it's fairly negligible, right? Spider is also transactional, which is great. It uses the XA transactions. So it's actually, when you have a transaction that uses multiple nodes, it actually creates a transaction so that these can be rolled back in case there's an issue. So basically this is how it looks. I mean, technically the remote table can be anything. So you could actually have separate types of tables depending on what you're doing with them. So depending on what the use case is. And the remote servers are not particularly Spider aware, it's all done by the Spider node. And you can you can have multiple Spider nodes attached to the same Spider cluster, similar to MaxScale, where you can have multiple MaxScale nodes attached to one cluster. So it's an easy way to do sharding, and it's built into MariaDB. So here's an example of how you do it. I create a table on the Spider node. I say partition by, and I give the partitioning scheme. And for each partition, I basically say where should that partition be, and that's it. And then on all of the backend nodes, I have to create the same table. But here, there's no mention of Spider because these nodes are not Spider aware. So then if I do an insert on the Spider node, it looks like one insert, but it will actually create 3 inserts. Every node will just get one of these rows. And there you go. So if you look at the performance of Spider, so basically, I mean, if you do key lookups, it's really fast. But if you do anything more complex, similar to NDB, if you start doing joins and things, it won't work as fast anymore. However, Spider has some optimizations for doing some things like if you have if you have small tables, like an auxiliary table that you often need for joins, Spider has actually built-in functionality for doing the joins locally. So instead of doing the joins on the Spider node, which would mean fetching all the rows first and then joining, you can actually tell the Spider nodes to do the joins locally and then ship the data. So you do have some optimization. And obviously for writing, inserts are generally faster because each node is independent. So basically you can scale writes, and that's pretty much why you would use sharding or Spider in the first case. Right. Any questions about Spider or sharding? The Spider node is failover design. So basically, you basically have another Spider node. So, I mean, similar to MaxScale, you would have 2 Spider nodes that have the same setup. You use one and not the other, and you have some kind of VIP in front. And then if the Spider node fails, you switch to the other one. But again, I would stress that Spider is not an enterprise-grade thing. It works. We have customers using it, but we acknowledge that it's not, enterprise-grade tool. So I wouldn't recommend it for anyone who doesn't know what they're doing. But obviously, typically the customers we've told them this, and they have a use case where they need something like this, right? So. I don't think so. I haven't heard of anything where it's built, because this is like low-level sharding, right? So typically the sharding solutions are above the database layer, right? And this is below. So I can't think of any that's like this either. All right, but so to summarize, I mean, just scaling in general. I mean, I typically agree with Peter, right? That sharding is a pain and you should avoid it at all costs. But there are, of course, reasons why you might want to use sharding. And I mean, Peter had an example about the customer who wanted to shard, and he started asking questions, and basically there was no real reason. There was they just wanted to shard because they heard it was a cool thing to do, right? And we've had similar, even worse. We had a customer who had performance issues, and so we started looking at what they were doing, and they were sharding, and they were sharding with 16 nodes, right? And they were using an external tool for sharding, and they basically had 10 gigs on each node, right? And we looked at their traffic, and it was the same. They had they had a couple of hundred queries per node, and so we asked them, why are you guys sharding? It's like, well, because we contacted the sharding company and then they told us to shard. I was like, well, yeah, they had sold their sharding technology to them, right? And so we were like saying, well, I think we said, well, the best solution to your problem is actually to use one node. Get rid of all the sharding, put everything on one node, because their performance problems were with complex queries where they had to aggregate data from all of these nodes. So yeah, we have these conversations a lot, right? So you should only shard when you really have to, right? When there's a really good reason to it. You have a table that, typically it's one table, but it could be more than that, but something like that. And if you have a high read ratio, these replication was built for read scaling, right? So if you have a high read ratio, just use read scaling. Don't start by doing sharding either. All right, any questions? Yeah. So is Galera a commercial product or is it free? Galera is open source, so in that sense it's completely free. There exists, so the company behind Galera, it's called Codership. I think they're going to change their name to Galera, but they basically just build the replication part of it. It's an underlying library. So what you want to do is you want to get a binary with this built in. So you can either get Percona XtraDB cluster or MariaDB Galera cluster. And in MariaDB 10.1, the Galera is built into MariaDB, so it's not a separate binary. Before Maria 10.1, it was a separate binary, right? But after MariaDB 10.1, you basically just get MariaDB and you enable Galera, and it's there basically. Galera is great in the sense that it's synchronous, right? So you can use it. It's a very good HA technology as well. But then it depends on your load, because Galera is a bit more complex. So standard replication has a lot of drawbacks. It's more complicated. You have slave lag and all this stuff. But if you have huge amounts of reads and you need to scale to like 30, 40 servers, then I wouldn't use Galera. So it kind of depends a bit. Galera is great for like a smaller use case where 3 nodes would be enough, or maybe 4 or 5 or something. But if you need to scale massive, then Galera is probably not. I would probably do like a Galera. And also another thing with Galera is it's synchronous, so you don't want to have them far away network-wise. So you would want to have all nodes in the same data center and things like that. So even if you use Galera for HA, I wouldn't use Galera for like for a remote data center. I would use standard replication from one Galera to the remote data center, for example, right? So standard replication for a larger amount of nodes, and Galera more for HA from that point of view. Any other questions? All right. If not, thank you very much for listening to me this long. And have a good conference.
Can everybody hear me? Hopefully? Okay, cool. I don't know what happened here. Okay, for those of you that just came in, actually there's some papers going around. We're raffling off 3 t-shirts and a little performance, a database monster at the end. If you're interested, there's some sheets going around. Fill it out. Put your name. There's a brown bag going around. Put it in there, and I'll ask at the end too, and we'll quickly raffle them off. Just to get started, this presentation is on need for speed, best practices for MySQL performance tuning. Just before we get started, a little bit about myself. I've been a DBA going on for, oh gosh, over 25 years now. Started out with Oracle version 3, if you can imagine that. And actually I've done many other databases throughout my career. Most notably right now, MySQL, I actually worked with it version 3 and 4 in the early 2000s. But we just know SolarWinds makes monitoring products, and so we have a product. Last September we came out, we're now monitoring MySQL. This isn't about SolarWinds, this is about performance tuning, but I just wanted to tell you where I'm from. I came to work for SolarWinds going on 9 years now, and there one of my tasks is to work with our prospective customers and our customers, looking at problems in their databases and giving them some ideas on how to tune it. And there's always this common kind of, deer in the headlights look when they find that SQL to tune. It's like, well, where's that magic button? What's going to fix it? I don't know what to do. So kind of the reason for this talk. I'll take questions at the end. It's I've got some case studies and stuff, so we'll take questions at the end if we can. The agenda, we're going to talk about the challenges of tuning, who should tune, what SQLs to tune, and then we're going to talk about a technique or a methodology we've used, or I've used for years, called response time analysis. I feel that's the best way to quickly find the SQLs to focus on and also give you great clues on how to go about tuning them. We're going to talk about gathering details about the SQL that you're going to tune. We're going to look at the explain plan and examine the best way, the best execution plan and how to find that. I use SQL SQL diagramming or query diagramming. Anybody familiar with that? Okay, good. Well, good. We'll have a few people in here. It's a great way to give you clues to find the best execution plan. So we'll go through that. It's kind of like a little scientific way for you to think of how to tune without having tools tell you. And then finally, we're going to go through some case studies. And then at the end, we'll talk about monitoring to make sure it stays tuned. Okay, so let's get started. Let's face it, I think SQL tuning is hard. And the reason why I think it's hard is because I believe you have to know a lot of expertise in many areas. You need to know how to write good SQL for one thing, because a lot of times when you tune, you may have to rewrite it. I also think you need to know how to read that explain plan and know how MySQL is going to access that data off disk and find the best way for each SQL statement. It's not always the same way, and it's not always, so I think you need to know that. I also think you need to know the business reason for that SQL. What's its purpose? Who's running it? How often should it run? I can't tell you how many times in my career I've worked with developers and they've, done some SQL, put it into production, and then they were just amazed that it's running millions of times a day when they thought it should run once or twice a day. So how many people are developers here, just out of curiosity? Okay, DBAs? Do about anything? That's what my Twitter tag is. Okay. So a lot of times the business side of it is really important to know. Years ago, I worked for a manufacturing firm, and every month end, they complain about the database. It's slow. And it's like, okay, what's going on? So we started looking around, and here this accounting clerk was running these reports, horrendous reports. They're taking 8, 10 hours to complete. And we started looking around to see who was using them, and no one was. She inherited a job from downsizing, was instructed to run these reports and file them. Nobody even looked at them. They were obsolete. That was the quickest way to tune that situation, just to shut them off, It's always not that easy. But tuning takes time. Large, there's a lot of SQL statements in a database, I've seen Peter's presentation, what do you say, a million SQL statements a second or something can go through? There's different SQL statements running in MySQL. And not only do you have to find which one to tune to get your biggest bang for your buck, but your solutions to tuning it is not going to be the same. There's no cookie cutter approach to any different SQL statement. Low priority in some companies is another challenge. A lot of you, how many have vendor applications? Not too many, good. Because a lot of times they tie your hand and you can't tune them. Or a lot of people, how many have tried to throw hardware at a problem? Did it work? For a little while? I bet you come back to it at the end. Inefficient SQLs will eat up resource. And the bigger the data grows, the more it's going to eat up. So, sometimes that's a challenge. Challenge of tuning is also never ending, but that could be a good thing, especially if you're known as a good tuner in the company. People will seek you out, and that's a good feeling because you're affecting something in the company at least. Who should tune? That's another challenge. Developers, you think they should tune because they wrote the code. They know the application. Oftentimes, though, they're not focused on tuning. They're focused on a deadline. You developers out there, how many of you have been given a deadline before you've even gotten the functionality that's needed? Yeah. I always love that one. You want it when? Well, then what do you want? But, okay, so they don't have time to focus on tuning, and oftentimes they don't have an environment that looks like production, so even looking at it running in a development environment might be the wrong plan, that it isn't working in production. And a lot of times, and I worked at one network company, they were Java developers, and they used Hibernate to create all their SQL. Awful SQL, but they didn't know how to write SQL, so that's kind of a gotcha there. DBAs, you think they should tune because they should know how to write good SQL. However, they're often focused with keep the lights on. In this day and age, do more with less people. How many DBAs here are responsible for 50 instances? More? How about more than 100? Okay. I mean, I've seen some awful, some DBAs having an awful number of database instances they're responsible. So finding a SQL statement within a database and tuning it, that's a time they just don't have because they're trying to keep everything up and running. So I think the best thing is to do a team approach. And I really do think tuning should be a project. I get mad at DBAs when they, go in, shut their door, and tune for an hour. Don't tell anybody what they're doing. Because really, I think it's a team project. You should call it a project. Get the end users involved, get the developers and DBAs, and actually, tune it and show it to your upper management. Because it's the only way you're going to get the biggest bang for your buck by tuning your databases with little time and little money. So, great way to get back resource. As I said, finding the SQL to tune can be a problem. How many people have tuned something and nobody noticed? Okay, good, there's a few. Yeah, you kind of wonder if you're working on the right things then. If nobody notices when you're tuning, well, okay. I've used these methods in the past to find which SQLs to tune. The top one there is easy. You got an end user complaining. You go about tracing their session or looking at what they're running and actually working through the SQLs they're running. Or if a batch job is running longer, you look at the queries within it. But if you want to holistically tune, I've used these other methods too. I often will sort my queries by I/O. I'll look at the rows examined versus the rows affected or sent and compare that. And if I got a lot of rows examined for the results that they're returning, then I know they're inefficient queries. And I'll tune them and reduce that down. You'll see me use this in my case study as a metric to compare against as I tune. You might want to find your high-consuming, CPU-consuming queries, because if you can tune those, you can actually give resource back for other processing. And then finally, what I'm going to talk about here is high response time. DPA, our product, uses that, but basically we're going to look at the performance schema and the information schema and get some good information out of that to find not only which SQLs we should tune, but we'll get great clues on where to start tuning. What is response time analysis? Well, if you think about it, historically, most databases look at health metrics. You know, they look at their statistics in the database, they look at their server, you know, and see what that is. But if, you know, and the conventional tools often caused, you know, finger pointing. It's one of the monsters we call. Blamosaurus is one of the monsters in our database because, you know, conventional tools just don't get you to the root cause as quickly as looking at what the end users are waiting on. These are just, this is my only funny slide, but I thought I'd put it in here because these are monsters, and I relate to them because, and I actually have a few more that I could put in there. But you've got the performance hog, you know, the one that's hogging up all the resource, and you're having to wait because of that performance hog. Or you got the virtual vandal. If you've actually virtualized your databases, you don't know what resources you're actually getting for your database because they're being taken from you or moved around on the fly. You got the time sucker, trying to find the right the SQL to work on. And then finally, the query blocker, who's blocking everybody else in the database, and they're just sitting and waiting. Blamosaurus we talked about, but look at that last one. It's a dev obstacle. And that's most of the DBAs that have taken on bad code and are afraid to put it in production because they don't want any more messes in their production database. So anyway, you can probably think of your own monsters that are happening in your databases, but just think about them that way. Response time versus health metrics, well, just think about it. How do you figure out the fastest way to work? Do you look at your gas gauge or oil? Maybe you look at your speedometer. But how does that help you if there's a wreck up ahead or a slow school bus, or maybe you got that one stoplight that you swear they keep slowing it down your way each time? You know, you probably use navigation tools like Google Maps or whatever to see that and try to go around that roadblock and try to find the fastest way to it. And so if you think about that, that's what MySQL and most of the database types that I've worked with in the past, they've instrumented themselves, well, either what we call wait or thread states. And so as you think about a SQL request going through a database, it does hundreds or maybe thousands of steps. Well, these databases not only record off the time each step took, but it also records off the resource it either waited on or used up. So then if you think about that, if you collect that data at that detail, you can quickly see where all the time is being spent for your end users, as well as getting clues on where to focus on tuning. If it's spending all its time on I/O, would you want to add more CPU? I mean, you could, but it wouldn't help you. So you need to know what resources and where to focus. Just a show of hands, anybody on 5.5 still? Okay. Earlier versions? That's good. When 5.5 is when the performance schema came out, actually. And actually, you can see down here at the bottom, I have, it had 17 tables in the performance schema. At the beginning of 5.6, everybody on 5.6? Or most everybody? Okay. 5.7? Anybody on 5.7 yet? A few? Okay. Well, 5.6 and above, they greatly improved the performance schema. It used to be a kind of a performance hit when you accessed it. It's not so much anymore. It gives you more information, 52 tables it has of 5.6. It gives you current historical events at all levels. You can get it at the statement level, the stage level, and weights. So MySQL has actually instrumented itself so granular at the picoseconds. To me, it's just amazing. It's one of the better one that's actually instrumented that you can get all that good detail about what your SQLs are doing and who they're waiting on and all that good stuff. And we're going to go into that. Beginning at 5.6, performance schema consumers are now turned on for default, so no longer do you have to try to configure all that. And then the storage engine now defaults to NODB instead of MyISAM, which is great because it's that transactional data. Now you can get blocking, locking, and all good stuff on exactly what your queries are doing if you're using NODB. In 5.7, if you're not there yet, even more improvements. It actually has 87 tables. They've reduced the overhead and the footprint greatly, so you can use it. You can actually poll that and get good information back. In fact, they've instrumented in 5.7.10, that's what I've got loaded, 1,005 instruments. You know, and you can turn those on. They come out with a number of them on by default, but now they've instrumented transactions, metadata locks, memory usage, and all good stuff like that, so you can get really pinpoint where your SQLs are running. When I say thread states, basically, can't remember how many thread states they have out there. It's hundreds of thread states that you can actually look at. And each one of these thread states are documented, not only what that state is doing, but what solutions you can do to actually reduce the time spent on those thread states. So here's an example of sending data, and this is kind of one that's used a lot, and I can kind of zoom in here, and you can see sending data is when MySQL tends to perform large amounts of disk, usually doing read. So it's saying who should resolve it, but you can get solutions, basically, look at number 5 there. You look at your rows examined to your rows affected. If it's more than 10 times that, then you need to tune that SQL statement. And it gives you solutions on how to. Now, the manuals have that out here. This just happens to be an example of what's in our tool, but you can go to the manuals and get the same information. So that's what I'm talking about, that you're recording off when you query those performance tables. Now, did I skip a slide? Because I thought I had. I have it. It's coming up. Okay. So here's just an example. We had a developer in our office that decided that he was going to look at each one of those steps. And just to show you how granular MySQL has instrumented itself, remember I said it instrumented the statements, the stages, and the weights? Well, he actually issued this one command. It's select, let me go up there so you can kind of see, select visibility from LinkDB link table. It's just a test. We're passing some parameters, and he had it for an update there. And you can see all the stages and weights that it went through. You can see that first it did an init. You can see the event time there, the statement time, and then there's the actual thread state. Okay? You can kind of look down here. I'm not going to go through all these steps, but how granular each step and how much time it's spent. And you can kind of see here, there is my weight of 11%. Weight I host table SQL handler, which means it's going to disk. You can see that it's doing a fetch. Okay? Above that was 17% of the time was spent on statistics, and that was coming from the statistics stage there. So knowing that data and concentrating on those expensive steps is a great way to tune, because that's going to quickly point you in the right direction on where to focus to tune. How do you get this information? Well, this is the performance and information schemas. Now, I haven't listed them here. I can kind of go through them. In the information schema, and if you haven't, how many know what that is? Anybody not know what the information and performance schema is? Okay. The information schema is metadata about all the objects that are sitting in your instance, your MySQL instance, okay? It's going to give you table definitions, constraints, all good stuff like that. The performance schema is a real-time database, if you will, that records performance information as it's happening. Now, it does it in current tables, that real-time that you can look and see what your threads are doing right this minute. And it also has historical and long historical tables that give you a little longer time of history. So you can get good information from this. Now, I've only shown you the current tables here. So in the process list, notice I can get the process ID. I can join that to the performance schema's thread table. And from there, I can get user, host, DB. I can get the command it's running. I can actually get the time. And you only want to look at your active sessions. So the state there will either be active or idle. And you don't want to poll idle sessions. And then finally, you can get if it's been instrumented or not. And you take that threads table and join it into the performance schema events weight current, which will not only give you the event name, but if it's working on an object, it'll give you the schema, the name. If it's an index, it'll give you that, and the operation that it's doing. Question? No, this is just the performance schema within MySQL. Yes, this is MySQL Workbench. Yeah. Yeah, and I actually go into that in a little bit, so I'll talk about that a little bit later. But then you can join threads into the event statement current, which will give you the digest, the SQL text. Notice my rows affected, rows sent, rows examined. If I wanted to just get a quick hit, I could go to this table and sort by rows examined and bring back rows sent or affected and kind of do that comparison. I could get my top SQL statements right there. and know where to focus. Because what is the slowest component in a computer? Anybody care? What? Disk access, I/O, yeah. So physical disk is the slowest. So if you can reduce that, you're going to speed up your queries. Okay, so then from there you can join the threads into the InnoDB transaction table, which is in the information schema. There you can get not only the SQL again, but the tables it's using, as well as if it's locked. If there's any blocking going on. And that's where you can dip into the InnoDB lock weights. That's in the information schema as well. And you get the blocking transaction ID and get the thread for that. So you can actually see the blocker and the waiter, which is nice if you have locking blocking. How many people have locking blocking problems in their databases? Okay. Yeah, it's nice to see the blocker when you do that. So basically, if you were to take these 5 or 6 tables, and this is not all the columns by any means. And like I said, there's 87 now tables in the performance schema. So if you're not familiar, it's worth it to go out there and acquaint yourself with it, because there's a lot more information. But if you wanted to do response time analysis, you could just create a query that goes on these tables, pull it at some interval, put it in another table, and then you can rank your SQLs. We do it with a timestamp. We pull every second this information, put it in a table, add the timestamp, and then you can sum it up and see, okay, not only I know how long it spent total time, but I know how long it spent on any thread state. So I'll get the expensive thread states and start tuning them. Here's just a quick screen of how response time analysis graphically can show you real quickly. And I actually tuned this one. What this is basically a chart of 24-hour period. Basically, the different colors are the different SQL statements. And you can see here, I've got this kind of olive green one that's running. Spent an awful long time. I don't even know what it spent. What did it spend on this day? 10 to 11 a.m. It actually spent 35 minutes out of the 63 minutes of all the activity of the top 15 SQL statements. So pretty hefty, 57% of the time. So if I tune that, I could give up to 57% back to my top 15, right? So you can see that in that hour, it executed 1,050 times. And average execution was 122, or a little over 2 minutes each execution. So pretty sluggish. That's my top SQL, and I can see that real quickly just by putting in that one table and pouring it back. Actually, I looked at it, I tuned it, and what response time analysis can do for you can give you really quickly how well you've tuned it. So here it is after tuning it. It's now taking 12 minutes. 5,000 executions as opposed to 1,000. So not only did I reduce it to 9 seconds per execution instead of 2 minutes, I increased the throughput 5 times. So great things to brag back to upper management. I'm doing my job, that type of thing. I don't know. But just quickly, another blocking issue. If you have blocking issues and you go to those InnoDB transaction tables, you can get the blocker, how long they've blocked, and who they've blocked. And not only that, what they were running while they were blocking, as well as the waiter. And this is just an example of that, where we can see that this one SPID, he caused 235 seconds of wait. You can look at his details, you can find that. He was actually updating stock. These guys were all trying to select from stock for an update. So they had to wait. So it gives you a clue of where to focus if you've got locking issues. Here's a scenario for you. Which scenario is worse? I have a SQL statement, number 1, executed 1,000 times, caused 10 minutes of wait for an end user, waited 90% of its time on sending data. Or I had SQL statement number 2, executed once, caused 10 minutes of wait for an end user, waited 90% on a system lock. Which one's better? Which one's worse? Anybody care to guess? I'm sorry? Well, which one, as far whatever you think, which one would be worse for the end user? Or? Great, you answered it correctly. End user doesn't care. He's waited 10 minutes. Yeah. But developers might see number 2 as being more difficult because it could be a concurrency problem, as opposed to sending data, which may be able to be resolved by adding an index or, restructuring the query a little bit. Okay, so we've got that SQL. We found the one we should be working on with the response time analysis. What do we do with it? Well, the first thing I do is I gather baseline metrics. How long does it take now? And then find out what's acceptable. Especially if you're getting to tune a lot, because you want to talk to your end users. If they have something running maybe 10 minutes, they want it down to a minute or two, that's probably okay. But if you've got an 8-hour or 10-hour process running and they want it sub-second, it may be more than just a tuning issue. It may be a design issue. So set your expectations and only tune to that. Don't tune it to the nth degree, because I'll tell you, you'll burn yourself out. You'll get yourself into a corner and you'll never want to tune again. So just set that. I always gather rows examined and rows center affected as well, because I want a metric as I tune to compare against. If I'm tuning a query that has 1 million rows examined, and when I'm done tuning it and now it's 10 million rows examined, I don't think I tuned it, right? I want that reduced. So you want to have some metric. I like that one. There are other ones you can choose. And also gather the thread states. Locking, blocking, system lock, I/O is sending data, calculating statistics is, of course, statistics, thread state. Network down is writing to net, or slow down. Some SQLs may have more than one issue. What I usually do is I will start with the biggest weight, time spent on which thread state, and first tune that, because a lot of times the thread states will change as you continue to tune. And just remember that all of the thread states, many of them have different resolutions, so when you look at them. After you've documented your metrics, you want to get the execution plan. And basically, MySQL gives you many different ways to get that. You can do explain, just a simple explain, or you can do explain extended. That's the one I like, because it's going to tell me how MySQL is going to transform that query after I've entered it. So it's kind of a neat way to see maybe you can improve how you code. Optimizer trace is available in 5.63 and above, and I've got examples of all these, and then MySQL workbench. Oh, here, I want to back up just a little bit. Let's just go through explain plan to see how you get explain plan to work. Is you just put explain in a session and then give it your SQL statement. And this one I'm actually, I've downloaded SCaLE, the little DVD rental store out there. I think Percona has it. But you can, play with it. And so I had this load going. And so the select title, first name and last name from film, and I'm joining that with film actor on film ID. And then I join it on actor ID. And I'm looking for last name like percent Peck percent, or first name like percent Angelina percent, So I'm just nonsensical query. But as you can see here, I used aliases. And so the explain in MySQL is pretty easy to read. You just read it top down. So the first thing it does is it goes into actor, which I've aliased as A. And this is something, if you don't have to alias with MySQL, I wouldn't do it. Sometimes you can't avoid it because you're accessing the table twice. But if you don't have to alias, it doesn't repeat the table name in the explain. So if you have lots of tables, it's kind of hard to read. But anyway, that was just the reason why I had that circled there. But you can see the first thing it does is it's doing a simple type into actor, and it's looking at the primary key, but as a possible key, and it decides to use IDX extra full name. Okay, and then you can see the key length, the number of rows it's going to do, and it's filtering in on the where clause. Then it dips into film actor, and basically decides to use the primary, and it returns 13 rows there using the index. And then it dips into film, again using primary, and returns 1 row there. So you can kind of see how that works. What's neat about this next cheat sheet, hit the end actually, this is kind of dated, but I like this chart, and I actually printed this out because it's a great cheat sheet to actually see all the piece parts within the explain plan. You can see here, this column over here, you can kind of see, let me see if I can actually get there. This actually identifies all the columns and what they are, but then you can actually see that over here, it gives you the definition of the type. The type is actually the data access, actually the most selective to the least selective. So you can see the top one is system, and then constant, and the bottom one is full table scan. So just kind of a neat cheat sheet to look at. It also gives you a great way to actually see what's in the extra columns, and what all that means. So I don't know. You can, if you download my slides, I don't know if we post them. I'll figure that out. But if there's a place to post them, I will post the slides so you can have it. Here's an example of extended explain. And basically, all you have to do when you do that is come in here and do explain extended. Now you can see I'm not using the aliases, so that's why it makes it a little nicer to read. Same, same plan. I'm not going to go through the plan. But what you do is when you use the extended explain, at the end you do show warnings, and that's when it's going to come back and it's going to give you what MySQL transformed the query into. So if you have implicit data conversions, if you've done a select star, it's going to actually translate that into readable for itself. And notice it actually put in the database in there, even though I didn't have that there. So kind of a neat way to learn how to write better SQL. I mean, why are you making it transform it when you should write it in the first place that way? So just some thoughts. Optimizer tracing, anybody use this? I thought this one was pretty interesting. It gives you all kinds of good information. How you use it is basically you set optimizer trace and enabled equals on, and then you run your SQL statement, and then you set it off, and then it actually stores the trace information in the information schema called optimizer trace table. So you can select from that. And you see it kind of spits out a lot of information. In fact, it will tell you every join consideration it was going to do. And it'll tell you all the filtering predicates. It'll give you all good information about costs that it thought about and all that. It's quite wordy. And you can see this thing that I've got circled down here, missing bytes beyond max mem size. It only puts, by default, 16K. In this table. So if you've got a table with lots of joins, it's going to fill it up right away and not report it all. So just realize you can actually change that setting, and there's a couple of them here. Just before I go on to that, though, notice this is how you set it off. Just optimizer trace enabled equals off there. Yeah, up here, let me go back up here. You can see set optimizer trace max mem size. You can set that up. So if you want to see all of the trace, you can do that. Just realize it's in memory and you're taking up memory. So in production might be want to be careful, especially if you've got a huge query that you're using. You can also set optimizer trace features greedy search equals off, which will make it not as verbose. It won't go through all the join transformations that it has to consider. So you won't see those, but it'll give you a decent plan. In fact, I couldn't list all the plans here, the whole plan here, because I couldn't get it on one slide. But you can kind of see the row estimates, the cost there, of all the tables that it's going to do and how it decided to use the plan it did. If you get a execution plan that you think MySQL is stuck on, I would trace it to see why, because this is very useful information. MySQL Workbench, another one, is great. If you haven't used Workbench, I'd recommend you download it. It's a neat tool. This is where you can do ERDs really quickly, which I'm a great believer in doing an ERD of the join of your queries, of the tables in your queries, because you're going to see the relationships. And I can tell you, I can't tell you how many systems I've worked on where the developer didn't know the full relationship. He got the right answer, so he quit. But you need to know the full relationships between the tables and put them in there. That gives the optimizer so much more information to do better queries. This is just that same query in Workbench. You can do tabular or visual. And what I like about Workbench, it's going to show you the expensive steps. And so it marked that red as expensive. it actually goes through and says, cost can be high, especially for large indexes. And then it goes in and tells you that. Okay, we looked at the execution plans. We know the expensive steps. So what do we do with it? Well, let's go get the table definitions. And first of all, is it really a table? Is it a view? You might have to first look at the view and tune the view. I like to use this one little utility called MySQL show -- that is, and you can give it the database name, or you can actually get specific and give it a table, or you can even do database table column if you wanted to. But I just did the database here, and you can see it'll print out the tables, the rows that it thinks it has, the average length, the data length, the index length, and the data free there. So it just gives you a good quick way to see how many rows you're working with within a table. I also think it's important to examine the columns and the where clause. Know the cardinality of those columns. Are there indexes on them? And if they are indexes, are they multi-column? And if they are multi-column, what is the left leading? Because MySQL will only use the left leading in an index. If you don't have that left leading column in a multi-column index in your where clause, it won't use it. Let's see. Also know if there's data skew, because that can make it do different plans at different times depending on the values you're passing. Okay, I think I got all that. Also know the cardinality of the indexes as well. How selective are they? And their sizes, because actually MySQL will look at the size of the index and kind of make silly decisions sometimes. And I think I've got a case study that shows this, where I didn't even reference the column that the index was on, yet it used the index. And the only thing I could think of was the size of the index, and why it would do that. Okay. So we've got all that good information. Well, we haven't tuned anything. So I like to use case studies to actually go through and show how to tune. I think it kind of brings it home. And plus, we'll talk about SQL diagramming. Okay, the first case study here deals with, and it actually was a real-time customer that called in and asked us to help him. It was a university. And they were trying to answer the question of who registered yesterday for their billing system, because they billed their students as they signed up and all that. So I changed it a little bit, and all the timings are on my little laptop, but it actually did come from actually this was an Oracle database, but I kind of transferred all the data and just to see if I could do it in MySQL, and it actually behaved just the same way. So anyway, we were trying to answer the question who registered yesterday for SQL tuning, and we're selecting student name, first name, last name, and registration sign-up date. From student, we're joining that on registration and on student ID, and then we join it to class on class ID. And we're looking where class name equals SQL tuning, and the registration sign-up date is yesterday, if you will. And then where our canceled equals in. The registration table was historical in nature. They never deleted from it. If a student dropped or canceled his class, they just mark it with a Y. So it was a very large table. When I ran this on my laptop, you can see 9,320 executions an hour. Average execution time, 9 seconds. Look at my rows examined. And look at the rows I got back. And look at what it was spending all its time on, sending data. 99% of its time sending data. Actually, what I did is I used MySQL slap. Does anybody use that? It's kind of a utility out in Linux that you can use. And you can say, okay, I want these many connections. I want you to iterate this over this query these many times. And you just give it a query. Or you can give it a script. And and then what I did is I actually put it in a loop and I changed the date. So this date was kind of looping through the last year or whatever my data set was. So it was never running on the same day just over and over again. And so that's why it had zeros rows, because nobody registered on the day that I looked at. Let's look at our response time data. Well, here we can see it's spending all of its time on sending data. There's a little table meta data lock that I'll get to, waiting for table meta data lock there. But you can see it was spending almost 10 seconds. It dipped down a little bit. You can see the throughput here was going up and down as amount of time. That's the executions. And then finally you can see the rows sent. And like I said, that day was, days were changing each day, and there was 0 rows, nothing had registered. And we didn't get until probably around where it spent more time, almost 13 seconds on average. We're looking at hourly data. But it actually, the throughput went down, but it started actually getting data, if you will. So it actually had a result set that came back. So you kind of see how it was running. Not pretty sluggish. We go get the execution plan, and what MySQL Workbench said, you've got a very high step here. Full table scan on student, almost 9,000 records, right? So, and then we're going to do nested loops into registration using primary, and we're going to get 4 rows. And then we're going to look nested loops into class and get 1 row. And of course, our very high cost, large tables, no usable indexes found on this table, so it's telling me all that good stuff. Well, how do I know how to tune it from looking at this? Other than that little thing about might be very high large cost for large tables. Well, that's where SQL diagramming comes in. And if you don't know SQL diagramming, I don't know this man. Probably sold him a lot of books because I always have him in my talks, because I really believe in SQL diagramming your queries. And it's a great book to download and use. He not only goes over this, he's just a great tuning reference. But basically, what SQL diagramming is you're going to take your tables in your query, and you're going to draw an upside down tree. And what you're going to do is you're going to take your detail table as your top, which in our case is registration. And then you're going to draw links or arrows out to your lookup tables, or your master tables, if you will. And so if you remember our query, our detail table was registration with a lookup into student and a lookup into class, right? Okay. So then the little numbers on the side, these little numbers here on the arrows are basically your join condition. So for this relationship, we're saying for every 1 student, he probably has about 5 hours of courses in registration for this year, right? That's probably a decent load at a university for a semester. And then for every 1 class, there's probably about 30 students. Probably not so for a university, but stay with me. Okay, so the join criteria, basically how you do that is for every 1 student, I should never have to read more than 150 records out of registration. If I'm reading 1 million, I've got a problem. Okay, so that's what you do with the join. The little numbers with the underline here are basically your filtering criteria. And if you remember, we had 2 filters on it. On registration, we had where registration sign-up date was between yesterday, if you will, and where our registration canceled equals no. And out of that, we had 4,228 records out of 79,981 records in the whole table. So if you look at that, about 5% of registration would have to be read with that filter, right? Our other filter was on class, where class name equals SQL tuning. Well, we had 2 records come back, probably different levels of tuning, out of 1,000. Well, 0.2% of class would have been read, right, with that filter. Which is a better filter? The more selective filter? Class, right? Okay, so we want to drive this query by going to class first, because remember, I don't know if I said it already, but really when you're looking at tuning queries, you want to read the least amount of data and then build upon it, as opposed to reading all the data everywhere and then throwing it away at the end. I mean, isn't that a waste? So we want to find the driving table. So I think class is our driving table. So let's go look at our ERD, like I like to do, and find our relationships. And you know what? No relationships. Well, right there is a big red spot here. And remember I said I got this from Oracle? Well, I transported the data over from Oracle and forgot to bring the keys. Now that would have given MySQL, because MySQL uses foreign keys very good. And so I don't know, how many of you use constraints or do not use constraints would be a better question. Okay, well just remember, if you don't use constraints, you're actually kind of tying the optimizer's hands, because that's giving him more information on how to go about creating explain plans. So I forgot to add the constraints. And not only that, when I showed the indexes, you can see I have an index here, primary keys, and my primary key and registration is on student ID, class ID, and sign-up date. Okay? I have a primary key on a student ID out of student and a primary key on class. So let's go add those foreign keys. And here you can see I'm doing alter table registration, add foreign key. On student ID, I didn't give it a name. It'll create its own name. And I reference the student ID, and I do the same thing for class on class ID. References class ID. And then I make sure they're there this time by selecting from information schema key column usage. You can do this to see your constraints. And I'm looking for table schema equals CSU and the table name equals registration. And you can see here, I not only get the table name, the column name, but the constraint name that it automatically gave to it and what the reference columns are. Let's go add the index. I'm going to add it on class name because remember I want to drive it by class. So I create index on class name or class NM on class name, rerun the explain, and you can see now I'm driving it. Very efficient. Class name, 2 rows, nested into 38, nested into student with 1 row. Much less than that 8K it was initially reading the first time I did it. Did I improve it? Well, here we go. As you can see, it was running really sluggish. Here we can see that, 13, upwards of even 22 seconds up there at the top at the end. You can see that little metadata lock. That's when I added the 4 keys, that little purple sign. I don't know if you can see that very good. But notice my class name, when I added that index, during that 1 hour, after that, it just went through the roof. Executions per hour, 86,000. I think I was doing 9 before, 9,000. 432 milliseconds per execution. 2.7, remember it was like over 750 million it was reading before with no rows. 2.7 million examined and 1.1 million returned, so pretty good. It's, usually you don't want it more than 10, you want it way less than 10. Still doing most of its time on sending data, but look at very little in the milliseconds. So great way to see that we've tuned it. I'm running out of time. We'll make sure. Okay, nope. Second one's just a little more meaty. I actually created, like I said, I downloaded the SCaLE database. This is a DVD rental store. And then I created these queries. They're kind of just my contrived. What I have is a master-slave environment, and what I set up is on the master, they were doing, I had all these customers renting and, paying overdue payments and, all this good inserting, updating type of stuff. And then the slave was doing all the reporting. So this happens to be on the slave, and we're looking for overdue DVD rentals by customers for last month because the sales reps needed to call them and say, come on, return the DVDs, will you please? And so this select statement is actually looking at customer last name, first name, phone number, getting the film title, and the rental date. And it's going from rental, and it's dipping into a customer on customer ID. Then it's joining to address on address ID. And then it joins to inventory on inventory ID. Then finally joining to film. And then it's looking for rental return date is null because it means it's still out. And rental date, and it actually does an interval with film rental duration and looking for the last 31 days to see if it's still out there. And then it's looking at customer last name and, passing that. And when we ran this, it's ordering by rental date descending. So when we ran this, it was 950 executions per hour, taking on average 2 minutes each execution. Again, look at my rows examined. 424, so about 500 million rows examined, 59 million returns, so but still pretty sloppy there with all the rows being read. And of course sending data, and you'll see sending data is going to be the thread where if you do have IO intensive queries, it's going to mostly be on sending data. Now, I have a really poor VM environment that the SAN is horrible, so all my queries are on that, so it may not be that way for yours. This is the response time data, and this, if you remember, this chart probably looks familiar. This is the one I tuned, and that was a query I was running. But notice it was, here's just the sending, the actual executions, 2 minutes on each execution. You can see taking a lot of time. It was the top one in my database. We go get the explain plan again. And here you can see, of course, all the good stuff. But here's the explain plan. It first dips into film. It doesn't use any keys, and it reads all the records, full table scan. So 3,679 records. Then it dips into inventory. It uses that IDX film, foreign key film ID. It gets 1 record. Then it dips into rental. And it gets 49 records, and it's using aware. And then it dips into customer using the primary keys, as well as in the address of primary keys, returning 1 record. You can see the transformation there. I always think that's easy, good to look at. Let's diagram it to see if that's the way we should really drive that query. So here, we've got 5 tables here. Our very detailed table is a rental with a lookup into inventory and customer, and then inventory has a lookup into film, customer has a lookup into address. And you can see we're saying for every 1 film, there's 3 in inventory, and for every inventory, we have about 94 rentals. And we're also saying for every customer, there's 1 address, and for every customer, there's about 91 records in rental. So again, you can do the math and figure out how many records you're going to join. In all actuality, if you make sure your join columns are indexed, left leading, however you've indexed, and make sure that it can use that index, MySQL is going to do the right thing. You don't need to figure out the join data. Just make sure they're indexed. What really matters, and in fact, when I do SQL diagramming, I don't even bother with the join numbers. I just go for the filters. Because what really matters is you're trying to find the driving tables, and the filters are going to do that. So we can see we had 2 filters, 1 on rental, 1 on customer. Customer was more selective. We can see here it was 0.2% on customer. And how I did that, because I was doing a like, is I got the average count of last name and I counted them just to see what would be the average to kind of figure that out. So 32 similar names were in there, and so that was 0.2% versus the 7% of rental looking for return date. So I want to drive with customer. So let's go get the ERD, and lo and behold, there is an index on customer. Well, why isn't it using it? Correct. Sloppy coding. Sloppy coding, because it's not going to, can't do the B tree because it doesn't know where to start. So it can't use the index. It has to do a full table scan. Other ways to fix this, we might be able to concatenate a field if you have to use this %. Concatenate, use a multi-column index and try to maybe put it on rental date. Well, you can't use return date because it's looking for is null, so it doesn't keep nulls in it unless you concatenate that with another column. So I just know this is, me being a sloppy coder, I put it in my little load routine and just a % and, a parameter and passed different names to it. And so I fixed it just by taking it out. And so when you do that, you see that then it's going to use the index. And so instead of that 4,000 records or so, it only looked at the 32 that it needed and actually got in there. So did we tune it? This one was kind of funny because, yeah, we did tune it, and I kind of forgot it because I had it iterating 1,000 times. Well, I sped it up so much, it got done. So you can see, I missed a couple hours because it wasn't running anymore. And I'm like, oh, I did pretty good because it went through the whole load. Okay, last one, and I know we're running out of time. This one is just more meaty. I did 11 tables here. And it was trying to, it's mainly to show you how to diagram, but a weekly sales report by category, by region, And again, you can see all the 11 tables here. Very sluggish, taking 5 minutes each execution. 110 executions when I ran it without doing anything to it. You can see this is where it was kind of funny. I didn't even reference this column. So it dips into film, but it's using this index, IDX FK language ID. I didn't reference the column, so I don't know why it decided to use that index other than the size of the index. I don't know. Then it actually dipped into film category and all that. And as you can see here, again, reading all the tables and then throwing them away at the end. So look at the number of rows examined too. 233 million. The rows affected was 2,000. So again, very inefficient. This is where I was going, why isn't it using the primary key? It seems like that would be a better way to do it, but because that's more selective, the cardinality, primary key. This one, it had 2 values in it, so maybe that was why. And maybe it thought it was equally distributed. In all actuality, there was data skew. So probably not a good reason to take that. Here's diagramming that out just to be more complex to show you how you can do it. Again, notice I don't put any joins there. I just go for the filters. And I'm saying staff has the best filter. So we're going to go put, oh, shoot, I didn't mean to do that. We're going to go put an index on staff. And when we do that, you can see that it rearranged it a little bit. It still had to go through a rental and look at some information and use those. But it actually really did improve it. The throughput, went down to 920 or 40 milliseconds, most of it in sending data. And look at our rows examined. Instead of 233 million, we're doing 15 million now. And we're affecting much more rows because we increase throughput. So finally, monitor is the last step. Prove that your tuning made a difference. Brag about yourself because no one else will. And just keep remembering tuning for the next opportunity. Work on the right sequence to tune. And, shameless pitch for our product. Download us. We got a 2-week free trial. There's a summary. I'm not going to go through that because I know we got this raffle. But if you want to stop by our booth, I've got this little infographic that, it's a kind of neat little poster that's 12 steps in MySQL tuning. It's just a neat thing reminder. Stop by our booth. It's 531. You can pick it up for free. Or if there's some place you can download my science and you're a cat lover, there's a 12-step program for cats too. Okay. Thank you, guys. Yes. Sorry. I'm sorry, yes. Yeah, it visually helps a lot, to do that, but yeah.
That's what I was wondering. That's my key question. That's SolarWinds?
Yeah. Then we're going to do a raffle. Does anybody have a little brown bag before you all leave? And you can your stuff and one quick raffle is taken off. People are leaving our house.
We'll send me your results out. Send me what you said. Somebody comes in and just sending this is 5.5 how that and then you carry that down.
If you need to go another one before you pick, you can decide to choose or go through. Okay. Sorry, Ricardo, Canto, I'll answer your question. Ricardo, Canto? Oh, you're there? Come on up. Yeah, you can either take a T-shirt or a monster, whichever way. First come, first serve. So. Here, I'll give him the draw.